I believe you may be able to hear me and see me. Um, I am remotely at the moment. I'm in the chat. Let me go back to the chat. If anyone here is able to hear me, could someone give me a sign? Maybe type something in the element room. I'm live? Okay. Well, in that case, I guess I'll just, okay, we can hear you. In that case, I'll just start talking. Um, and that sounds great. And every now and then I'll flip back and forth to the element room that I'm watching because I'm, of course, joining remotely. So hello, everyone. Richard Littauer. I'm here to talk about using floss to plan your daily exercise by birding. This is going to be like the least technical talk. There are technical things in this talk, but as is my tradition, I just tend to talk about the tech I make to do stuff with birding. This is a yellow-legged gull. I took it in the Azores. It's very far from Seattle, but it's quite nice. I'm also far from Seattle. I'm in Costa Rica, where I've been birding for a while. Costa Rica is pretty dope. Highly suggested if you want to go birding. Um, so many birds, can't even. Okay, let's just begin. No, I don't know. Okay, if I just press that, great. Who am I anyway? Hello. So I'm a linguist. I'm a Latin tutor. I'm a developer for my sins. Forgive me. And I'm a community manager. I don't really know what that means. I always put that in quotes. That's fine. I currently work at Sustain OSS talking about sustaining open source software. That's a picture of me in blue from when I wrote the Avatar Na'vi dictionary. Used to like languages a lot. Hey, Kaylee, good to see you. Who is this guy anyway? Well, why am I here to talk about birds if I'm all those things? Well, I'm also these things. That's not me. That's my dad, but let's pretend it's me. I'm a Washington County, Vermont birder. That's where Montpelier is in Vermont. It's the capital. Very small county. I'm an unaffiliated ornithological academic, which is kind of nice. I'm in the wrong room for this talk, which is great. I like how I just threw a bunch of birds at people. Yeah, I'm using StreamYard, Colin. Thanks for asking. I'm not using OBS. I like OBS. Um, I think I'm in the wrong room. I'm just going to sip my coffee and say hi to my dad and just sort of hang out until things get resolved. Um, Kaylee, it's good to see you. I wish I was there in person. I hope you're doing well. Salt, I wish I had a kilt on. Maybe I'll go back to the beginning and we'll just start again. Yeah, I went back to that link. I was in that link. Let me go back to that link again. So this is my StreamYard link, which is what I was using before. I'm going to close this.
so you can see if I'm showing on the microphone. Oh, I have my screen now. Excellent. I'm in the looks like I'm picture in picture now. All right, excellent. So we're ready to go. All right, so I'll go ahead and get started here. So welcome to Linux like it was 50 years ago. And so my name is Jim Hall. I do a number of things in open source software. You probably noticed me from the FreeDOS project. That's a project we started back in 1994. It's a free software, open source software implementation of the MS-DOS operating system. But today I'm going to be talking about Linux. And so I've got a very, as you might guess from the FreeDOS background, a big interest in how technology kind of came to be, right? Sort of retro technology. And so I want to talk about kind of a little bit of Unix history here through the lens of Linux. Because when people talk about, Linux being, quote unquote, Unix, right? I don't know that people really understand what that really means. And so, when you think about what Unix was like 50 years ago, it definitely did not have, the graphical environments, mouse that we're used today. It was much more command line and much more text oriented. So let me talk about some history here. So the first version of Unix, the real first version of Unix was 1971 in November. And if you don't know the history of Unix, kind of backing up even a little bit further than that, Ken Thompson at AT&T Bell Labs, just Bell Labs, was working on optimizing some throughput routines for a disk drive. And, he got a certain amount of time into that project before he started to realize that, I'm actually only a couple of steps away from actually having an operating system. And so he decided really, I think it was like 3 weeks away from an operating system. And he said, I just need to write an editor, which will take me about a week. I need to have a kernel, which will take me about a week. I need to have a compiler, which will take him about a week. And so he was able to do all of these things, he thought, in about a 3-week period. Around that same time, his wife was going to depart to go and visit the relatives. They had a new baby, and so she was going to basically take the baby on the family tour for 3 weeks. And he's like, wow, those two timelines line up. And so he had 3 weeks uninterrupted, he said, where he was able to create the first prototype of Unix. But it started really in 1971. It's really the first real version of Unix. That was called first edition Unix. That's how we refer to it back today. And it ran on the original PDP-11. In 1972 is when they came out with second edition. And the real highlight there was that that was the first time we really had a C compiler, right? So you think about all the programming that was happening on Unix up until then, on the first edition, it was really being done in assembly. I mean, there were other things too, but really it was being done in assembly. And so 1972 is when we had the first real version of C. Now it was similar to the versions of C that we use today, but it was obviously more primitive, especially the way that you would define functions and things like that. And we'll get a little glimpse into that today as well. Third edition came in 1973, and that was the first version of Unix that actually supported pipes. So if you think about it, before then, in versions 1 and 2, if you wanted to run the output from one command into another command, what you actually had to do was to send the output of one command to a file. And then when you ran the next command, you had to do the input coming from that file, and then again, saving it to another file if you wanted to run it through, let's say, a third program. And so pipes really was the power move there on Unix third edition, the real power edition, because it allowed you to connect different programs together the way it was described, kind of like a fire hose, right? Sort of a garden hose where you can connect different hoses together to make a longer hose. In this case, it was connecting programs together to make a more complex command line. But each individual component was just a program that did one specific thing and did that thing very well. 1973 in November was fourth edition, and that is, we're pretty much actually at 50 years now when we get to November, because it's November right now, right? Early November. And that was sort of the first public view of Unix. That was the fourth edition of Unix. Fifth edition was about 6 months later, and that was in 1974. And that was really available to higher education institutions. Commercial licenses came later in sixth edition in 1975. 1979 is skipping ahead there. That's when we had seventh edition. That's really what added the Bourne shell. That was really the big thing in Unix seventh edition. Longer times here between version releases. And so in 1985 is when the eighth edition came out. And that was really only intended for education. I'm not saying that other people couldn't get a hold of it, but it was really only intended for education. Ninth edition in 1986 was more of a conceptual release. Now, at that time, you really had the commercial licenses out there. The commercial Unix systems were pretty well enforced in 1986. And so you had things like Sun Microsystems, and you had other companies like that were running their own Unix. 10th edition was really the last research edition, and that was in 1989. Now, looking back at what those commands were like in first edition, so these are the commands that were in the first edition of Unix. We think about Unix having a really rich command line and capable of doing all these different things, but the first version actually couldn't do a ton, right? So just a couple of things to point out, right? This definitely had a Fortran compiler. Ken Thompson believed that any computer system of that era really should have the ability to compile Fortran programs. And so it had a Fortran compiler, and I seem to recall that the name, I actually could look it up, I guess, but the name of that compiler was called FOR, F-O-R, which we can't name that today because Bash shell has a for loop built into it. And so when I run a Fortran compiler later on, it's going to be called F66. But there definitely was a Fortran compiler, and there was also a basic environment that you could run if you wanted to run basic programs. There was also AS, that was the assembler. And then ROF. So ROF is interesting to me because there was a program written by Jerry Saltzer on another computer system, MITS, that he used to write his thesis on, his thesis proposal, and then later his thesis. And there were other systems that you could use to create documents on computers, but Jerry Saltzer just needed something that would just do paragraphs and basic formatting and things like that. And so he wrote a system called Runoff. And that was the full name, Runoff. It was actually all caps in that system, but it was Runoff. And so Runoff would read a file, and it could use dot commands, right? It would have these dot commands that you put on a line by itself. We'll look at what that means when we actually look at an nroff file later on. But you could actually provide formatting on a line by itself, starting a command with a dot, and then you could do things like adjust the line spacing, or add some vertical space, or change the indenting and things like that. And that was a cool thing. The ability to use a computer to generate documents, printed documents, was a pretty cool idea. As I said, there were other ones. I've talked to Jerry Salzer, and he said that there were definitely other systems before his. He's not claiming to be the first, but Bell Labs saw it, and Bell Labs thought that was pretty cool. And so one of the engineers at Bell Labs created a version of that, sort of a runoff could support longer command names. And when they did ROF, they used abbreviated command names. And so they used an abbreviated version of the program name itself. And so ROF is their version of the runoff command, the runoff text processing system that allow you to create programs. And so that's what ROF means. ROF is really just an abbreviated version of the runoff program originally by Jerry Salzer. It's obviously a complete rewrite. Now, second edition, Unix second edition in 1972, it added a couple of extra programs. Most importantly, it replaced ROF with nroff. And so the brief history behind this is that the Unix team wanted to buy a new computer system, and that was the PDP-11, and that was in first edition. And so they wanted to buy a new computer system, but the management had kind of felt burned because they'd worked on Multics before that, and Multics hadn't really gone anywhere. And they didn't really want to be an operating systems company. We don't want to be creating operating systems. We're Bell Labs. We do phones. And so they wanted to really focus on that. So I said no to the request to buy a new computer system that they could develop Unix on. Around that time, as the story goes, and this is told me by Brian Carnahan, and actually it's in his book as well, that around that time is when the legal department, which wrote patent applications, wanted to buy a new dedicated computer system that they could use to write patent applications. Now, patent applications have pretty specific formatting requirements. And the real interesting thing was that the system they were planning to buy, the software wasn't ready yet. And so Bell Labs, or the Unix team, rather, I should say, went to the legal department and made a deal. And they said, hey, if you buy us a new computer system, we will update the ROF system to support the formatting that you need to do patent applications. And that seemed like a pretty good idea. And of course, no one, quote unquote, is going to be working on operating systems, right? So we're really just supporting the patents team. And so they created a new version of the ROF program that could support these updated formatting instructions that they needed to do patent applications. And so the new version of ROF was named nroff. So if you're ever curious where the name nroff comes from, it actually is a new version of ROF, and ROF was the abbreviated version, used abbreviated commands that were used in the original runoff program. And so this version was also, of course, the first version to support a C compiler. I'm not going to go over every command in here, but those two things are pretty important. The ability to do C programs and the ability to use nroff rather than just plain ROF. And so this is what the Unix second edition manual looks like, published June 12th, 1972. There's Ken Thompson, there's Dennis Ritchie on the front page. And looking at the list of commands that were in this version of Unix, section 1 with the actual Unix commands, kind of short when you really think about it, just a little over a page. But again, first edition, there's ROF on the upper right-hand side on the second page there, towards the top, second line down. There's the ROF command that you can use to format documents. Now, I also want to point out there's another command in here called type. And so type, a little further down on that second page, would print a file page by page, because they were using teletype terminals. I got a photo of that in a second, but they were using these teletype terminals that normally would print on a big continuous piece of paper. We weren't using video terminals at the time, at this time, but the teletype printed on a big roll of paper. And you could actually eject the paper, and you could load a US letter piece of paper in there, and you could print to that as well. But of course, a piece of paper using the standard line spacing, you can actually do 6 lines per inch. And so with 11 inches on a US piece of paper, you've got 66 lines. And so what the type command would do is it would print 66 lines of output, and then it would silently wait for the user to press return. And that gave them time to let that first piece of paper jump off, and then it would wait, and that would give them time to load the second piece of US letter paper, and they could hit enter, and then it would just continue printing because that was the only output device. And so type in this case really means it's going to basically simulate somebody typing a document, but you're really pulling from a file that was generated by ROF in this case, because this is version 1 that we're looking at. Unix 3rd edition is where you've got commands like crypt and kill and things like that. There's now a C debugger in here. This of course has the ability to run pipes on different commands. We've now split bin into user bin, so now basically provides the ability to provide certain commands on a second hard drive. You can see some of the other commands up there. You can now look for unique lines in a file. You can split things up using split. Unix 3rd edition manual looks like this, right? So this is what the Unix 3rd edition manual looks like. And so if you can see, actually before we were looking at 2nd edition, sorry, and I claimed it was 1st edition because I saw ROF, but actually when you look at the actual manual, the table of contents says ROF, but the copy that I have actually further in where it actually has that page, it actually does have a title that says ROF. I don't think anybody updated the page. The page itself does describe nrof, the nrof command, but it was still updated in the manual to say ROF. Actually, you can see nrof. Actually, now that I look for it on the lower left-hand side there, you can see nrof as formatting text for printing. And so, a couple more commands in here, right? A couple more commands available to you in this version of Unix, and you can see that we've got the Fortran compiler program. I said it was 4 earlier; it was actually FC, which today would be file compare. But we're looking at that's the ability to run these different commands in Unix 3rd edition. And so, a couple of things to note: awk awk does not exist. There is no awk. Awk did not come until much later. Also, those of you who might be looking for me to talk about trof, trof wasn't here either. Trof was the typesetter version of the nrof command. And so typesetter, they bought it later on, a typesetter, which I won't go into big detail here because we're not going to demo anything like it. But typesetter is at a high level kind of like a laser printer. It's not, but it's kind of at a high level like a laser printer. What it really is it's a photo typesetter, and it it's an enclosed box, and so you put a piece of paper in, it can feed a piece of paper, and it has different wheels where it's got what are called fonts loaded. And so a font is just text of a particular type style, and so it could be regular text, Roman text, it could be italicized text, it could be bold text, it could be both bold and italicized text. So we got these 4 mounting wheels you can put in there that each have a font displayed, and it would shine a light through that one character that you're trying to print. It would spin the wheel, get to the right character, and it would shine a light through that at the right distance to make a letter of the right size, because it would shine it onto a piece of photos sensitive paper, basically like film, and then later would go through a basically developing and fixing process. And that's actually how photo typesetters worked. And you could get some really interesting effects by using a photo typesetter. It's at a high level, as I say, kind of like a laser printer today, but it definitely was a different process. I'm not going to really talk about trof or typesetters today, so I'm not going to go into trof. We're just really going to stick with the old style that was available to us 50 years ago. And so looking at the original Unix PDP-11, this is the original PDP-11. If you haven't seen this photo before, the person who's seated is Ken Thompson, and standing is Dennis Ritchie. And so they are seated at a teletype terminal. I've got a zoomed a picture of this in just a second, but let me see if I can zoom in a little bit further. You can actually see what this looks like. This is the teletype, and it's a standing piece of electronics. And so there's the base down here. And the only thing that's really the thing to note is that this device up here, I don't know if you can see my mouse, is the actual terminal itself. This is the Model 33 teletype. And if you're ever curious about why the Unix commands were so brief, why they were so short, like ls and rm and cp, it's because Ken Thompson said that the letters, to type a letter on the original teletype terminal, it required a lot of finger strength to push these electromechanical switches. And he didn't want to be typing that all the time. And so he was using short command letters to represent each command. But you can see here in the back, this is where that spool of paper that I mentioned comes into the system. It spools down, and then it goes to the print head, which is behind here, and then it continues up. And that's what we're seeing over here. You're seeing a little sheet of paper, what looks like coming off this roll, but it's actually coming out of the teletype and resting on top of this this spool. And so that's him typing some commands at a teletype. And so that's him using a teletype. Now down here, this is a better photo of a teletype. This is a picture of a teletype that I took at a computer museum in Wisconsin. I live in Minnesota, and so Wisconsin is the next state over. And it's a little dusty, but this is actually an original Model 33 teletype. Now, it's a little different from the one that we just saw in the photo above. If I scroll up real quick to the photo above, you notice there's this piece of electronics kit to the left of the keyboard, and that is a paper tape punch system. And that is missing from this model down here. This is the Model 3310. Which I think was also called the ASR, which was automatic send receive. If I'm remembering the model number correctly, I definitely know this is a 3310. But basically, the Model 33 teletype here came in 3 different models. It had one that was the basic model, which is what you're looking at here. It had a different model that was the same teletype, but on the left-hand side was that paper punch system that would allow you to output code, basically, to store onto a piece of paper that you could then read into the system later, like it was being typed into the terminal. And then on the right-hand side, there was a third model that replaced this blank panel with a built-in modem. And so that's what you would see here. That's why it's got a blank piece here, and that's actually why it's blank up here in the Bell Labs laboratory, because they didn't need a modem. They were directly plugged into the PDP-11. All right. They actually used the model later on. They replaced the 33 with the Model 37 teletype, which is actually a better device anyway, because it supported both uppercase and lowercase. What an amazing thing! So the original Model 33 didn't actually support lowercase. It could only display in uppercase. And so this was the teletype that they were using. Now, it didn't support 80-column printing. We think about terminals today as being 80 columns. This did not print 80 columns. An 8.5 wide sheet of paper at 10 characters per inch actually allows you to print 85 characters. But this one didn't even support even 80. It was like, I want to say 67 characters. And I might be misremembering that, but it's 67 is close. If it's not the exact number. And it was the same deal. It would piece of paper would come in, it would go through a roller and over a print head, and it would come back out. This was just enclosed in a little housing, so that way it wasn't quite as loud. A little bit further down here, the VT52. So the VT52 was introduced in the 1974. So just 1 year later than what I'm trying to present for 50 years ago. But video terminals of some other kind were still available since 1969. So I'm going to display some examples here, do a live demo using a video terminal. And it's meant to sort of simulate that actually, yeah, there were video terminals at the time. By the way, most Linux terminals today really emulate a VT100 with a whole bunch of extra features added to it, like color and things like that. But basically, Linux terminals today are not that far removed. I mean, we're talking about terminals like the terminal window you bring up. It's not that far removed from terminals from the distant past. And so, as I said, there's Unix 4th edition, which supports a bunch of other commands. But I'm really focusing on 50 years ago. But I'm really kind of focusing now that since this is, 4th edition is pretty much 50 years ago, it's not that different in terms of commands from Unix 3rd edition, right? So it's adding things like tr to translate characters. It's adding grep to search for text. There's an interesting story behind that, but I'll skip it. Com to find common lines, things like that. So you got different types of commands that are being added, but not a ton from Unix 3rd edition. And so if you wonder what it's like to edit files, work on files and edit files, let's actually bring up a terminal window here. And so I'm going to bring up this is the Cool Retro term. And if you haven't used Cool Retro term, it's basically trying representing what it looked like to be on on an old video terminal from that era. I could actually, flip this into different modes, like a green character mode or something like that. But this actually gives me a screen that's about, not about, it's actually 80 columns wide, and it's actually 24 rows tall. Now, actually, terminals at the time were actually 25 lines tall, but the last line was reserved for display from like status and things like that. And so it's okay that we only have a terminal here. It's 24 lines long. If I were to make it full screen, it actually would go to 25 lines, but we actually want to represent 24. And so let's look at something that somebody would have done in the era. So, let's try to write a very simple Fortran program. And I don't want to go like deep in on Fortran in this. We're just going to show how to edit a file using the ed editor and Fortran. I'm not trying to do a big Fortran demo, but just to write something that would have been done at the time. So ls, we're seeing that there's nothing in this directory at this time. Now, there's no VI editor, right? VI didn't come along until later on, written by Bill Joy. And so how do you edit files at the time, right? VI is the visual editor. And we certainly didn't have, like Emacs or, GNOME text editor or, Visual Studio Code if you use that, right? We didn't have anything like that. So we actually had a line editor called ed. And so I'm going to do an ed on a new file, and we'll just call it numbers .f. And so this is a Fortran code, so .f we use for the extension. And so it's telling me we don't have a file called numbers. And it looks, you might think actually we've got an error and something's gone wrong, but actually ed doesn't display a prompt by default. You could actually, in GNU ed, you could actually give it the capital P command, and that actually would display a prompt with a star. But I'm going to try and mimic what it was like 50 years ago. So no prompt. We're going to be like typing into the air. And so we're going to start inserting some new lines. I'm going to do that with the I command. And so I will insert new commands or insert new lines into the file. Since we don't have anything, we're now going to start on the first line. All program instructions in Fortran need to be written in all uppercase, and they need to start in column 7. So I'm going to do 1, 2, 3, 4, 5, 6. And we'll do a program called num, and we're going to define an integer variable, integer, that we'll just call I, because I'm lazy. I'm going to use a single letter variable name. And we're going to do a loop. And so you can actually have blank lines in there. It's the same as having nothing at all. And I'm going to say we're going to do a do loop, which is basically the equivalent of a for loop if you do other programming languages. But we're going to do until we reach line 10. And we're going to iterate the I variable. And we're going to start at the number 1. And we're going to continue until we reach 10. And normally when you write this in C or something like that, you would do a for loop, and you do I equals 1 and I is less than 11 and I plus plus, and then you would include the curly braces to start and end the loop. But actually here you're just telling it go until you hit line 10, and it's really not even a line number like everything is line numbered like from 1, 2, 3, 4. It's actually just what's called a label. And labels go in the first 6 columns. And so here is line label 10, where it's going to do a print command using some defaults, the variable I. And then it's going to end the program. Oops, actually, let's type it. Let's do a typo. EMD, right? And so that is, I've now created a typo on the last line, so I can go back and edit it. And that is my program, and I'm done editing. So how do I tell the system? How do I tell Ed that I'm done? I just do a dot, and so dot tells it that I have finished entering my my insert, and now I'm back to a regular command mode, and I can ask it to print out using numbers. We're going to print out all of our file. Now this is actually will tell us because I didn't give it any range. It's just going to print the current line, the last line that I left off on, which is line 7, or I could say I want to print out starting at line 1, going to the end of the file, and number out those lines. And so I could do that, or I could just say I want to print out only line 7, and I don't want to do the number thing. I just want to print it as it displayed in memory, and I can do P, and that'll allow me to print. So I can now replace 7. I'm going to do a change on line 7, and I'm going to do that as END. And now I'm done making that change. I'm going to do period, and now I can list out my file, 1, comma, dollar. You can also use percent. That'll do the same thing as 1, comma, dollar to print out the contents of my file, and you can see that that's my source file. And so if I write that file back to disk, it now has 85 bytes that is written back to disk, and now we can quit back to the operating system. And there I am back to my shell. And I don't have an FC command. I mean, FC would do comparison, but I'm going to do I have a script in here called F66. And if I just to display for you what that looks like, my bin F66 command is really just a wrapper to GNU Fortran. So if you want to do this at home, install GNU Fortran. All right, so we're going to run F66 on that. We're going to save the output to a command called numbers, numbers with a B, and numbers.f is the input file, and now it compiles that. And because we're using old style Fortran, hey, that was a deleted feature in Fortran 2018, but we're in 1966, actually 1970, we're in 1973. So we're gonna ignore that the warning. And so we actually now have a command called numbers, which you can now run numbers. And I could also write a document. That's the really cool thing here, right? I can write a document. So let's write a very short document in here. We're going to do it using nroff. And so we're going to do ed, and we're going to edit another file. And in this case, we're going to add a file that we'll just call SeaGL. Actually, they don't need to have extensions. nroff files do not actually have to have extensions. And so if I were to edit a new file called SeaGL, it doesn't exist. I don't have a prompt. And so we'll go ahead and type in an nroff file. Now, here we can just use a I want to create an extra line of space at the top of the file. And so I want to create, let's say, if it's 6 lines per inch, we want to add 2 inches at the top, and that'll be 12 lines of spacing. We're going to center, oops, that was meant to be inserted. And so it doesn't know what the .sp command is, Ed. So I need to actually insert a new line. Now I can do my .sp for 12 lines. That should be 2 inches if it's 6 lines per inch. And then I can also then say, we're going to center, let's say, the next 2 lines of output. And we're going to type in a simple nroff document. We'll add an extra line of space. It doesn't actually count towards the centering. So we'll add an extra line there. And then we'll say SeaGL 2023. Now I want to add an extra inch of space. We'll do space by 6 lines, and then we'll do a temporary indent of a new paragraph of 4 characters, and we'll say this is a sample document written in nroff. And so everything here is nroff will collect words and it will fill paragraphs. In fact, we'll type that in. The nroff command will collect words, and it will fill paragraphs. Now, I tend, when I write nroff files, I tend not to go all the way to the edge. This is an 80 column display. I could go all the way to the edge, but I've just learned over time, if I'm writing an nroff document, I just like to leave some extra space in each line. I also like to start a new line at the end of a sentence. And so the nroff allows you to use these dot commands. And so use the dot commands, which we'll put that in paragraphs there, dot commands to provide different formatting in a document. And then, for example, the dot .ti, oops, dot .ti, should have a period there, command provides temporary indenting on a paragraph, right? And you have other things in there like .sp will create a vertical lines of space. You can also do things like a page offset with .po. And so this is what we've got here in a sample document. So this, that we can just hit return there, and we'll do a new period to indicate that that is the end of my input. Ed doesn't tell us that we're done editing, but we are definitely done editing. And if I wanted to list out the contents of my file, I can ask it to start at the beginning and go to the end. And I can number out those lines. And so each one's going to be numbered. And so I've got 14 lines in my document. And so if I wanted to edit some things in here, I could certainly do that. And so maybe I didn't like the fact that a simple nroff document is in sentence case. And so I want to adjust that. And so we're going to do a change on line 3. So 3C will change line 3, starting at line 3. And I'll say a simple, and we'll put it in quotes, nroff document. And I'm done making my change. If I was entering any more lines here, it would keep inserting that after line 3, but I'm done. So I'm going to say period, and now I'm done with that. And now I can look at line 3 and just print it out and see, all right, now fix it. So it's no longer in sentence case, is now in more title case, right? So that makes sense. And now if I write that document back to disk and then quit back to the operating system, back to the shell, I actually now have a file. Now, we wouldn't print this on a terminal screen. We actually would want to print it on some sort of a teletype-like device, some sort of a printer-like device, sort of a typewriter-like device. And so we don't actually have that with the video terminal, but we can actually simulate it. So I actually have a shell over here, which I'm going to bring up on screen. And so this is, it's unfortunately zoomed out, but that's okay. We just want to see what the text looks like. And this is just a GNOME terminal that I brought up that has 80 columns of width and actually 67 lines long. Now, I said before that a US letter piece of paper is 66 lines long. So why am I doing this as 67? Well, it's because I don't want the first line to roll off the top of the page. So if I were to print out a list of numbers. Now, the sequence command, or SEQ, doesn't exist in this old version of Unix, but I'm going to do it for you anyway, just because I want to. It's the easiest way to print 66 lines. I'm going to do a sequence from 1 to 66. And so there you can see line 1 at the top of the screen and 66 at the bottom. And the 67th line is my prompt waiting for the next output. Now, when I print on a piece of paper, it's going to be printing at 10 characters per inch horizontally. And so if you think about an 8.5 by 11 sheet of paper, that's going to be 85 columns. And so I actually don't want this terminal to be 80 columns wide. I want this to be 85 columns wide to simulate a sheet of paper. And so there's 85 by 67. But the teletype doesn't actually print out 85 columns. I said earlier that it can only print out to like 67 columns. If I have the number wrong, it's not too far off. And so let me bring up my other terminal and I'll lay it on top here. And I'll make this one 67. So if it's not actually 67, it's pretty close. It's basically, I'm going to be kind of simulating the output here. And so I'm going to lay this one on top of my other shell. I'm going to kind of center it here. And so again, it doesn't matter that we can't actually see the full contents of the output. The thing is, we're going to be looking at the formatting of the output. And so here I've centered approximately my second terminal on top of so the terminal sitting on top is 67 columns wide, and the terminal behind it is actually 85 columns wide, because that's how wide an 8.5 by 11 sheet of paper looks like. So basically, you can imagine the terminal that's got the numbers on it is simulating the full width of a sheet of paper, and the terminal I've got brought up on front of that is really the width that a teletype terminal is going to be printing back to the screen. And so as it generates the output, we can see that it's going to print it out on that system. And so we're going to do an nroff on SeaGL file, and it's going to print out 66 lines. It's got some defaults built into it in terms of, it definitely it knows that it needs to have page length of being 66 lines long, because that is a US letter page. You could change that if you needed to as a parameter, but we can, or as a command, dot command, but we're gonna leave with the 66 lines for a piece of paper, because that's what it was on a US letter document. And so if I run nroff on the SeaGL file, again, nroff doesn't care about file extensions. And so normally we'd use an extension like .nro or .me if we're using the me macros, which I'll talk about in a second. That would, you'd be tempted to do that, but nroff doesn't care. And so it's going to read the nroff SeaGL input, and it's going to now generate this output. And so you can see that it's got 12 lines, which should be 2 inches at the top here before it gets to a simple nroff document. And there's our SeaGL 2023, and it's got another inch of space, or 6 lines after that, before we get to our body paragraph. And our body paragraph has a temporary indent of 4 spaces over here on the left. And so this is what it would look like if you're going to run this now through the type command to actually print out a document on or type it. It looked like it's going to be typed up on an 8.5 by 11 sheet of paper. The defaults are set up, I think, pretty well, so that way it kind of simulates typing on a on a document with the margins and things like that, because it almost goes to the right hand side of the page. And so you can imagine that there's a pretty good gutter here on the left and the right that looks pretty good. But if we wanted to, we can edit that. And so the way that people would typically do this is they would create a new file that they could just use everywhere. So I'm going to edit a new file using ed. And we'll do this, we'll call it page. And so page doesn't exist, and so it's going to complain a little bit. So we're going to go ahead and insert a new command here that's going to be a page offset. And so this is here a little bit small. So let me see if I can make this a little bit bigger. And so that should be better. And so we're going to do a page offset on, let's say 7 characters into the document. And I'm going to also make the document shorter. And so we're going to set the line length to, let's say, 60. I didn't do this map ahead of time, but I'm kind of imagining I've got an 85 wide column piece of paper. I've got a 67 columns that I can print from my teletype, and so I'm trying to add a little bit of space on the left and shorten the line so that way they don't fill up. So I'm trying to balance the page. So I've got enough columns on the left and enough columns on the right. 60 is probably too short. I'll make it 65 characters wide. And then I'm done editing that. And if I did a comma. So this is a period. And so I want to now delete line 3 because that's a comma. And so I'm going to do a full length of my document, and I'll just number them out real quick. And I'll delete line 3. So 3D will now delete line 3. And if I think that 7 characters is too much, maybe I want to get that down to page offset of like 4 characters. I could edit line 1. So I'm going to do a 1. C to change that. And actually, you know what? I only need to change the 7. I don't need to retype the entire line. This is not a very long line, but I don't need to change the whole thing. So let's just do a change on line 1. We're gonna switch some characters around, some strings. We're gonna swap And then inside these slashes, we're going to change the 7, and let's change it to a 4. Now, if that looks familiar, it's because you probably have used sed, which is the stream editor. And yeah, it is using some, the S command to swap text. This is where it came from. If you use VI, you can do the same thing. You can do colon, and then you can give it a range of text, and then ask it to switch text from one thing to another. And then the text that goes between the first, from the first slash to the second slash, that's the text it's going to look for. And then from that slash to the next slash is going to be, that's the text it's going to swap it out with. And so here, we're only going to operate on line 1. And we're going to do some swapping of some text. And we're going to specifically swap out the 7 for a 4. If I thought there'd be more instances of this text on the line, I could do a G to make it global per line. But this is actually, I only have one instance to change. So I'm going to do 7 to 4. And so now I've made my change. Again, you don't get any output. Ed doesn't tell you that it actually has made that change. But we can now see that it is. I now know I can see that's been changed because I can look at my file, and I'm going to do a $1, $$ to do the entire file, and we'll just print out the contents without any line numbers. And so you can see that the first line is now a page offset of 4. Right, so this is really interesting history. That if you ever wonder where some of these editing commands came from in VI, in sed, and things like that, they actually are coming from the original ed editor. All right, so I'm done making that change. Let's go ahead and write that back to disk. And I'm going to now quit. And then I'm back at my shell. And so now I've got a file in here called page and another file called numbers. And let's swap back to my output. So again, just so we can kind of see what the output looks like. Now, the command I'm going to run here is going to run nroff on the file page. And then SeaGL was the nroff file I wanted to work on. And then that would actually generate a new document. Now I've zoomed in here, and so I'm not actually going to be able to see enough of the document, but we're going to do this now on a full page simulation here. So there's my teletype, and over here is my output that's going to be on top of that page. And so this is the teletype on top of the actual output. And we're going to run that nroff command using page as the input. And then we're going to do SeaGL as the second file. And so the page has now, I haven't changed the SeaGL file, but page now has the page offset, which basically gives it a left margin. And I've now changed the line length so that way I can hopefully get this centered a little bit on the page. And it's not correct because my page offset has now moved me back a little bit. So if I just a real quick edit that, do an ed on the page, and let's display the whole file. And I want to change line 2. We're going to swap that 65, and I originally thought it was going to be 60, and that actually should be what I want to change it to. So we'll change that to 60. And that has now been changed. And so we'll print out line 2, now 60. We'll write that back to disk, and then we'll quit. And we can go back to, this is my 8.5 by 11 sheet of paper. And on top of that is my command, and like in my teletype, and I can run nroff on the page, and then SeaGL. And there we go. If you can kind of imagine that this teletype output is sitting on top of an 8.5 by 11 sheet of paper, it looks like what's on the left-hand side going all the way to the edge of the paper is about the same as what I've got on the right-hand side going to the edge of the paper. So I basically have now created a document like it was 50 years ago on a teletype style printer, a terminal style printer, that this is how you would create documents back in 50 years ago. And we can do all of this on a modern Unix system. I'm running Fedora 38, and all these commands exist. You might have to install maybe the nroff package and the ed package, but they are all still available today in 2023. So I know that this zoom out here is kind of hard to read. So let me maximize the screen, and I'll just zoom in a little bit so you can actually see what this file looks like. And I'm typing in here. And so that is what the output looks like on my screen. And so you can see it says on the first line, a simple NROF document. There's that SeaGL 2023 right after it. And then the paragraph itself says this is a sample document written in NROF. The NROF command will collect words and fill paragraphs. Use the dot commands to provide different document formatting in a document. For example, the TI command will do temporary indenting of a paragraph. And so I had to pick a font that was about the right width, and I had to increase the spacing between characters to make an output kind of look right. But this is what it looks like on a piece of paper from 50 years ago. Anyway, I'm going to go ahead and pause there. If there are any questions, I'd be happy to answer questions, and I'll look for the moderator to put them in the chat if we can. But otherwise, thank you very much for your time today. I'll stop screen sharing. And so while we're waiting for our questions to come in, so the brief summary here is that Unix, we think about Unix or Linux being Unix. It's always the term that kind of people bandy around, that Unix, Linux is Unix, but it actually is more than Unix. Unix from 50 years ago, certainly, Linux certainly looks like Unix from 50 years ago. Linux even looks like Unix from the 1980s, but Linux has added a whole bunch of other commands, and it actually is now a very feature-rich environment that Unix didn't really go to. And so it really can simulate what it feels like to be on a Unix system from 50 years ago. Now, we got a great question here. Curious if you're using a line editor in my day-to-day work. And that would be interesting. That would be really interesting to do line editing for all of my daily work. No, I actually do use full screen editors. But I will say this. When I started sort of exploring this topic of what it was like for Unix from 50 years ago, I actually did an experiment where I actually ran my Unix system, my Linux system, like it was a Unix system from 50 years ago. Now, I didn't do it like all day, but like for like an hour a day, definitely for an hour a day for an entire week, maybe even 2 hours, I actually would try to simulate the work that you would do from 50 years ago in a Unix terminal. And I did that by using as you just saw, the cool retro term, and I would maximize that on my screen. So that was all that I was seeing on my screen. And I would write documents using NROF. I would write some little programs in C using ed. All of it using ed. And what's interesting is that you actually, by editing with a line editor for any amount of time, you actually start to think a little bit differently, because you start to build up this mental map inside your head about where things are located in your file. Are they the top? Are they the bottom? Things like that. Some questions from the chat, can you undo a change with ed? I don't think you can actually undo a change with ed. That would require ed storing some memory about what the previous state was. If you were worried about a change, maybe doing the wrong thing, the standard thing to do is to write that file back to disk and then run your edit that you weren't sure was going to do the thing you wanted to do. Because then if it didn't actually work, then you could just reload the file. And so that's really the way that you would undo a big edit in ed, is you just save the file. And then if it didn't work out the way you wanted to, you'd read it back into the ed editor. Someone's also asked, how hard is it to write a man page? Actually, not that hard at all. Once you start to get used to using ed and the different macros in NROF. I didn't quite have time to go through the macros, but you can define macros in NROF. You don't actually have to use just the NROF commands, raw. And in fact, very few people ever use the NROF commands just raw by themselves. You would actually create or stack up several commands at one time into what's called a macro. And so I might create a paragraph macro, at the time might be called like PP, that would, which is typically shorthand for paragraph, and that would maybe create a space, an extra space, and then would do a temporary indent. And so that way you don't have to keep typing those two commands all the time with an extra space and then temporary indent. You just do .pp. And so that's called a macro. And so you could build up lots of different macros with lots of different things. And there is definitely a macro package called AN. And so the way that you'd reference these different macro packages in nroff or troff later on was with the -m that says load this macro package, this macro file. And the AN file, macro file, contains all the macros to build a man page. And in fact, that, by the way, is why it's called a man page. It's short for manual, but -m for macro, you do it nroff -man, and then the name of your file. And as long as your file has the man page macros in it, like an sh to do a section heading and a indent IP for an indented paragraph, that would allow you to format a man page correctly. And so other questions that are in here, so it's clear how limitations drove innovation in the earlier days. What limitations do you think are driving innovation today? And so it's very interesting. What limitations do we have? And so, right now, I wouldn't say that it's probably being driven by limitations as more exploration. That's kind of how I view innovation today. It's kind of people exploring new things. We're seeing a lot of excitement around AI. I'm excited for AI as a concept. I'm a little cautious. I'm sort of divided because I'm also cautious about how we're using AI and how what it's developing its models from, and basically what it's going to iterate back to another user by generating text. But I would say today it's not so much being driven by limitations and more about exploration. Someone else asked, what was the first editor that I used? And the first editor that I used on a Unix system was actually VI. The first Unix system I used was in early 1990s, and when I was a university student, and I discovered our campus computer labs. And the editor on Unix that I used was VI, because that was the editor that we had on a Unix system at the time. It was the old Sun 350 machines. And so I used VI. But I did learn how to use ed on the old DOS systems before MS-DOS 5. If you wanted to edit a file, you use a program called Edlin. And Edlin was kind of derived from ed, had some very similar commands, and things just worked, like very similar to ed. There are a little bit differences here and there, but it's very similar to ed. So if you actually want to explore that, Jeffrey Peach on the FreeDOS project has actually created a version of Edlin that actually ends up being very portable. And if you're curious, you can actually run Edlin, FreeDOS Edlin. You can compile it for Linux. I've actually done that on my system. It's just C code, and you can compile it for a Linux system. There's even a configure script to get it to work on a Linux system. So you can absolutely run Edlin there. Another question that came in. So with the way that you can feed multiple files into nroff, it sounds like you could create various page files meant for different paper sizes and use those to print the same document. And so was what the creators wanted to be able to do, so they could print both patent applications and technical manuals without having to do a lot of fiddling with the document spacing in the document themselves. I wouldn't say specifically done that way so you could do it in for patent applications, but it was 100% intended that you could set up a set of files that basically stores a bunch of macro definitions, or in other ways, basically sets up your document. And then your document itself is in a second file. And actually, if you're writing something even longer than that, like you're writing a book, each file is probably storing a chapter of your book. And the way that the man pages work on Unix is each file is a separate man page. It covers a separate topic. And so you looked at the table of contents, and making sure that every one of those documents or those man page entries was actually a separate chapter or a separate section rather in the overall printed manual, and it was the same input file. They didn't rewrite them to work on to create a full printed document versus what lives on the system. They just ran a command that included all of those extra files with a separate file sitting up front that they would read up front that actually would process. This is now going to be going for a printed document. And so we want to make sure we've got a page offset to create a left-hand margin. We want to adjust the line length. So that way, when you do the left-hand margin, the page offset plus the line length, that you actually are kind of balancing the page. And so now you've got roughly the same amount of space on the right-hand side of the page that you had on the left-hand side. That's adjusting the balancing sort of the line length and the page offset. And so that way, yeah, you could just have a single file that says this is what the page layout looks like. And now you can print that man page to a printer, and it can and that will adjust everything so that way it'll be just fine. Now, if you wanted to print that on a legal size page, well, that's a different number of lines on a page. It's still the same width, but it's a different number of lines on a page, and that's just a different line or a different page length macro that says instead of being 66 lines long, now it's going to be, I don't know what the line length is for a legal piece of paper because I don't know how long it is, but it basically do the math to sort of figure out how many lines are going to be on a legal piece of paper. So yeah, absolutely, it was and they set up so you could feed multiple files into nroff so that you could have a set of macros or other settings in one file, and then another file or other files you could have the actual content of the document that you're trying to print. All right. It looks like we may have reached the end of the questions, so I'm going to go ahead and wrap up here at 2:40 or at 12:40. So thank you very much for attending my talk on Linux like it was 50 years ago, kind of simulating Unix from 50 years ago using the Linux command line. Thank you very much.
So we're on the dark now.
Yeah, and then you code drops.
Hey, that works. Okay.
Yeah, that's cool.
All right. You want to give Gopika Submarinians talk?
Yes.
Okay, great. You're live and you're recording, and have fun. I'm gonna go see what AJ needs. Thank you.
Hey, good morning, everyone. This is Secure Coding Fixed from Root. I am not Gopika. None of the people in this room are Gopika. This is going to be a bit of a fun community event as we try to figure out what this talk was going to be. As we go through slides, you are welcome to add in more color should you think that you have something more interesting to say than what I've come up with off the top of my head. And let's get started. I believe this is a half-hour call, so that
1 hour.
1 hour? Well, fuck me! We're doing it live, friends. Okay, so welcome to the room, and by the way, thank you everyone for coming to SeaGL today. About me, I am apparently a security engineer. That should be obvious at this point. I think I like dogs. I am a CTF, that would be capture the flag, one thinks. I'm a dog mom. And I am a monster is my handle on some of the socials. Okay, so today we're going to be talking about is secure coding, what problems you see in the real world. We're going to start off with web. You know, web's obviously one of the most important technologies we have these days. Everything is in a web browser. DevSecOps, has anyone heard of DevSecOps before? Anyone who's DevOps? Have anyone heard of DevOps? More hands. DevOps is, hi, we don't have a separate team that runs production. We do it all ourselves. You know, DevOps is when developers do both the operations and the development.
Oh, yeah.
You're not the author, are you?
No?
Okay, cool. We're doing it live.
Okay.
He's not here. DevSecOps is when not only do you have the development team running production as operations, they're also doing all the security. So you can do these often with CI/CD pipelines and try to use as much infrastructure as code. Third thing we're going to talk about, exploiting web technologies. And then, of course, lastly, fixing the bugs from root, going back to the actual location of the problems. So let's talk about your standard web architecture. Clients and servers. The client, the thing that I've got here on my laptop, that's my client, the server, somewhere in a cloud, in a data center, it's somewhere. It's all the stuff that's serving up that content. It's the endpoint for your APIs. It's the place that most of the work does. Everything that's not being visualized on your computer is probably on the server side of the world. So you got your client there, maybe it's a laptop on the top, maybe it's your phone on the bottom, the unfettered internet, a hive of scum and villainy. Then you got your application tier. So you might have some load balancers, you got some application servers, and then somewhere in the back end, you've got some storage. You've got maybe the databases because you got a dynamic site that is, maybe doing a shopping cart. Maybe it's providing, social information. You got to store that stuff in there. So you've got different tiers across your application stack. This is a pretty simplified view of what most things look like. Getting in a little further, getting more into the weeds, it's really easy to run everything on one box. That's pretty straightforward. That's simple, but it's not very performant. It certainly doesn't recover well if there are problems. If your one and only one database explodes, your entire site is down. So typically people will end up having a more complicated environment. So here we've got all the different components to run our infrastructure. One thing people forget about in the first place, DNS. Who knows what DNS stands for? Say it out loud. Domain name system, domain name service. It's the thing that converts, CNN.com to some 1.8.7.4 IP address. If there's a problem, it's never DNS, but guess what? It's always DNS. So your browser there hits DNS, figure out what's the pretty name mapped to, goes to CDN. Anyone know what CDN stands for? Just say it out loud.
Content delivery network.
Content delivery network. That's your Cloudflares, your Akamai's. Ways to offload some of your stack to somebody else so they can serve it faster from more places than my laptop at home. Your load balancers, when you have one web server and it goes down, it's a problem. If you have 10, works out better. So you put a load balancer in front. Its just job is to move the traffic to whichever web server or servers are available at the time. Maybe there's a reason to go for some of the URLs. Maybe it's just sending them all to all of my between neither.
What's happening in here? Room 2?
This is room 2. Welcome to what's the name of our talk?
Secure coding?
Secure coding, something, something.
Are you the person who's supposed to give this talk?
No.
Congratulations.
Are they
Neither
not
am
here?
I.
Wow.
We're just doing it live. It's a community show.
Okay.
So you got your load balancer, you got your web app services. In theory, they're all roughly the same. They all talk to one or more databases, which might also be load balanced. You might have a data warehouse. You got a data fire hose, drinking from the fire hose.
I just want to watch.
Oh, we've got more people.
So as your service is going on, you might have a bunch of backend services that are necessary. So you got your job servers. Maybe they're taking all those shopping cart things and moving them through a backend pipeline that's not directly user-facing, but is required in order to make the service, actually build a person, actually ship those pieces out. So you might have some sort of job queuing. You might have some backend jobs that aren't user-facing, but still are providing part of the function of the system. Anyone seen the OSI model? The application layer, the presentation layer, session transport, network data link, physical. I'm gonna say this right now. It's a bunch of hooey, lies, and damn lies. Who knows, like SOAP? SOAP is HTTP with XML with this and that. Like, where the heck does SOAP live on the OSI layer? Nowhere. Really, you want to simplify things down. So really, the top levels of this, application services. And it might be over multiple protocols. Transport, how does it get there? That's TCP, IP, that's ports, that's HTTP, that's FTP if you're horrible. So the different layers here are usually done on different parts of the components. Oh wow, it even says HTTP, FTP, SMTP. Whoever wrote this presentation is really reading my mind. I love it. Or who bought 1-year car insurance from AC Lombard at $2,000? I've never seen this scenario.
Wonderful translate this into format.
Next slide.
Oh, we got some templating going on. I think that's what I'm seeing here.
Tell me more. Tell me more.
Or I was going to say, it looks more like one transaction is really like 5 microtransactions, each of which is executed independently, maybe? But maybe what were you going to say?
Ooh, 1-year car insurance from, everyone speak up. So here are the different steps, and he pays for the insurance.
This might be different pieces of information that you can glean from the first sentence.
Yeah. How do you break up that human piece into all of the individual components inside your web stack? How do we actually complete all those pieces?
Wait, no, this is the layer. This is, look.
Oh, this is layers?
Layer, this is physical, the actual money.
Ooh, money is physical? I don't think that's how money works. Have you not been around since blockchain?
It's a layer.
I'm guessing it has to do with the layers and it's a metaphor, but it's a confusing metaphor.
Onions have layers.
I think there's different ways you can interpret that sentence. Yeah, it's
Yeah.
like syntactic ambiguity.
Yeah. If there's okay, so we're going to talk about the application layer.
Okay.
Hey, here's a web page URL. URL/URI, you're allowed to have your personal complaints about which one you use. All of these things start off and are broken up into little chunks. The scheme, the very first thing before the :// that is whatever the protocol is. For example, HTTP, HTTPS, FTP, SSH, lots of different protocols out there. The next thing is the domain you're trying to get to, which is usually broken up into smaller chunks. Working from the right to the left is how you go from biggest to smallest. So com is the biggest. Digitalgasm is the next piece, in this case www, but it might be cart, it might be wiki, it might be something. All of these things are in the DNS layer, so that's the host name. Then you got your path. This is on the web server where it goes to. So anything before this question mark is, let's say, a single script, if it's like, say, a CGI or something called like that. But you can also send it parameters, so it can be different depending on how you hit that particular page. So the query string, in this case, question mark, and you got a bunch of key value pairs. So in this case, we say source equals Google, medium equals search. You might have seen a lot of things, UTM _ equals whatever. That's one of those tracking things that is coming to figure out how you got there. So the query string allows a particular web page to change how it looks, depending on what you're requesting from it. Question.
If Daniel Stalberg were here, he would love to point out that this is not necessarily the final source of truth. There are corner cases in URL parsing, and different browsers, different command line utilities will sometimes break down break down URLs slightly differently depending on who you ask and when. Just fun fact.
One of the funnest examples is you can put a username password sometimes in your URL.
Don't.
Yeah. You shouldn't.
By the way, if you're talking, make sure you keep the volume up so that they can hear you. You also don't necessarily have to put it in the URL. You could be doing it as, say, a post where the data is coming in through the body.
I'm not certain, but I think it's that microphone there, the one with the
Sweet.
green lines on either end, so it should hopefully be picking up everybody.
Oh, excellent. Nice tech. Okay. Ooh, I think I know what we're about to talk about here. Okay, so let's look. Oh, you people. So let's look at some of these URLs real quick. Note that the first several are actually all of them are something.example.com. Example.com, by the way, that's one domain. If you're ever doing examples, please use example.com or .org or .net. They don't belong to anybody else. Please don't use ASDF.com. Somebody owns that. Don't use AOU.com, which is the Dvorak version. Somebody owns that. He's talking right now. Use example.com, net, and org. So we've got a bunch of different URLs here. Attack.example.com/dir/page.html. Attack.com dir2 index.html. Why are we talking about this? There are some things that are going to be sent from my browser depending on where I go. There are some policies around when you send data, notably around cookies. So if we look at the first two, they both are attack.example.com. You'll see in that third column, the reason it says same origin. If you get something from attack.example.com, let's say you get a cookie from that. When you go to the second attack column, it's going to send that cookie with it because it came from the same URL, or rather from the same hosting. If we look down to the third line, now we're going to ping.example.com. That cookie we sent from attack is not going to be sent to ping.example.com because it's from a different thing. Now you might be wondering, why do I care about that? You really need to scope where your data is sent. If I'm writing a web application with a cart, say, I need to make sure that that cart information follows me while I'm on the site, but doesn't follow me when I go to Reddit or to my bank. We wouldn't want to be sending this, banking session cookie to something that isn't it. Come on in, everybody.
All right, thank you.
For those who are just coming in, I am not the presenter, so we're making this up as we go along.
Oh.
Wait, no, where is the presenter?
We don't know.
can't find him, so
Her.
or her.
So, this is a community affair.
Okay.
Everyone
is
have
this their slides or?
Yes, we
Yeah,
have a
there's slides.
slideshow. We don't have the presenter.
We're doing it as we see the pages. It does explain a lot now, doesn't it?
Okay.
So data sent from the first URL will come through for the first, second, not any of, the last two, but if you look further, the reason why it doesn't come for any of the rest, so ping is a different host entirely. Example.com, different host because it does not have attack dot. Attack.example.com:12 is a different port, so it could be a different service, so it's not coming through there. And the last one is HTTPS versus HTTP. So again, that cookie we sent in the first one will not get through any of the last four on this list. And
It's
so
also
that's
a
a
different
security
port.
boundary. What's that?
It also happens to be a different port, but I presume that if you were doing HTTP and HTTPS and manually specifying the ports each time, it would still be considered a different origin because of the different protocol. Did not know that.
I would agree with that too.
If we want a real-life security application, I once did a security test for a client that had a horribly insecure by design feature they were unwilling to get rid of.
Oh God.
So we just told them, okay, fine. If you want to accept untrusted client data that can modify your website inside your server, put it on a different subdomain, please and thank you. And so there is a large company out there somewhere that is currently redesigning their entire websites to put a horribly insecure feature on a different subdomain because it does make things safer.
Using that security boundary to do an insecure thing as little insecure as possible.
Yes. Sandbox.bigcompany.com.
Please don't say anymore.
Oh yes, I know.
Okay, DevSecOps. This is the integration throughout the entire life cycle of a project of your platform, trying to not only have teams think about security, and development and production engineering all in one fell swoop. It is a way of, in an agile model of having a team think about all of these components and constantly push back toward them so that it's just feeding itself properly. So let's start off, where should plan be? Plan B is there in the middle. You plan, you decide what you're gonna do, right? Oh, we're gonna build the new death ray widget. You write up some code. We're going counterclockwise here. You write some code for the death ray widget, you do a build, you do some testing of that death ray widget, you put it into production. So you do the release. And hopefully all these things, other than when humans are doing work on code, most of this should be part of your CI/CD pipeline. Most of this should be automated. So we get it out in production, it's out there, it's deployed. Hopefully the thing is up and running. But do you know if it's up and running? Not unless you monitor it. So maybe you can have your monitoring not only using third-party services, but it also might be built into your pipeline. So it can say, oh, this didn't work, and it can force a re-release of an older version. Like the more time you spend making this nice little infinity symbol work automated, the more that you can sleep at 3 in the evening or 3 in the morning. I heard a thing you could say, a bad engineer gets called at 3 in the morning, gets paged and goes back to sleep. Good engineer gets paged at 3 in the morning, addresses the page and goes to sleep. A great engineer doesn't get paged at 3 in the morning. So DevSecOps. Everyone is responsible for security. Everything should be as automated as possible. And everything that can be automated through CI/CD should be. Go to your one and only one tool. Maybe that's GitLab, maybe that's GitHub, maybe that's something else. That's where all the work goes. Maybe the deploy old version is simply a button or an API call away, rather than you needing to go and running a bunch of Ansible.
Sorry to interrupt. Masks are required in the presentation rooms. It's on all the doors. There's a few people in here not masked.
There are masks downstairs
Free
at the
masks.
SeaGL stuff. So why is DevSecOps a good thing? It will help reduce the risks. If you're SOC 2 compliant, if you're doing any of those other compliance methods, the more automation you have, the better off you are. So DevSecOps can help you get and achieve those compliance measures that will let people feel comfortable running your service. It makes your SDLC, your software development lifecycle. How do I get code out the door in a reliable, checked by other people, QA'd by other people or systems? How can I get that more efficient? Your software delivery gets improved the faster you get this. The more automation you have, the quicker you can get out the door. I do a git commit. Somebody looks at my merge request. We push it out to dev. If it doesn't have any problems in dev, it magically deploys in prod 7 hours later. Automate the heck out of all that. Those fast results of getting stuff out the door, your bug fixes, your new features, the faster you can do that, happier your customers are, because they want those features. They want that bug fixed. So what are some important things that will make this go well? You want as much automation as possible. I think I've said that 25 times at this point. So anything you can automate, for example, static code analysis, you have tools you can integrate into your pipeline that will go and, it'll run lint across stuff. It'll find any problems. It'll, use various tools that you can integrate there, some of which these days actually come with your tool. You don't even need to shell it to something via, Jenkins. Do some analysis on the code and the code quality. That can be part of the review process. So someone says, I got 3 red marks here. I'm not even going to bother reviewing the code. Fix them. There's buffer overflow. There's whatever it is. But definitely have it as blocker, before it gets committed to main. Dynamic testing, have it run out there and do some real things. Security testing as code. Security testing, automation, or response. I hate the word SOAR. I just hate that acronym. But again, all of these are similar pieces of the pie. How can we easily automate as much as we can and have humans be there only for the parts that are necessary? Patching. Who likes patching? Isn't it? I see several hands up there. Patching is great. Job security. Does it bring me joy? No. Absolutely. Okay, I see some thumbs up for patching is fun. Okay, good on you. Okay, let's talk about some specific attacks. Who knows what XSS stands for? You answer all the questions. Anyone else?
Cross-site scripting.
Cross-site scripting. I knew you were going to get it. Don't get me wrong.
It also says that it's the first
Oh my God, it's the first line. I can't read faster than I'm going here. Cross-site script. How about someone give me a description of cross-site without actually just reading it? cross-site scripting. I know you know. I know you know.
It was my job for a while. It's basically, so websites are made of code. They've got a whole bunch, it's like HTML, JavaScript, stuff like that. Cross-site scripting is when you have a user input field where if it says like type in your username, and you type in your username plus some HTML plus some JavaScript, and now you can steal everyone's cookies because they did not properly encode the input such that whatever you type does not become website code.
And now I can become
Technically,
somebody
that's
else.
injection. That's injection, but the point is, the injection causes the website to call somewhere outside of itself that it shouldn't be calling.
Not always. It can be entirely contained to the website, but
I don't know if I'd call that cross-site scripting though, if it's in the same origin. It makes me think of origin control policies.
I think we're all talking. Here's what I'm saying. We have too many people who are too smart and are talking about too many things all at once, which is a great problem for us to have. There's actually, I think, a pretty picture of the cross-site scripting that the author was thinking of. You got your attacker. It's got the little devil horns, because of course. Attacker sends a user a bad link in email or whatever. The user's logged into various systems, right? The systems have cookies that are logged in. If the user goes and clicks that, then when they go to this site, if there is a cross-site vulnerability, that system will get the credentials that was meant for a different system. And that system that the attacker controls can then take those credentials and use them somewhere else. And those are probably, again, cookies or something. Or they could cause them to click a link that says, delete all Jira projects or something.
I thought that was a CSRF attack.
Yeah, I'm getting them all confused too.
Or something innocuous like figuring out what was in your shopping cart.
Yep.
Doesn't have to be.
How do those vulnerabilities work? Like, does the JavaScript engine not have any way to detect it, or I don't know?
I think you were not here.
Sorry, I did come in late, so I might have missed it.
You're using a third-party service.
So you were not here for this part where we talked about the different zones. So when you are crossing origins, when you're leaving one site to another, where is the security boundary for data that is sent from your browser to third-party things? Where does it think that it has crossed that boundary? Hold on.
Thanks. Sorry.
Okay, what do we have here?
these are the types of cross-site scripting.
There we go. Apparently there's xssgame.appspot.com that can show you more. I will go look at that later. Okay, JavaScript. JavaScript has events. This is how it can know to do things at any given time. Some of the most common events that pretty much everything has, onload, runs a particular function when? Come
Page
on.
loads?
When the page loads, when the page, on the load of the page. On air, can trigger anytime that there's a problem. On focus, oh my God, any of those things that are watching your mouse movements and stuff like that. On click, this is probably the only one I've ever implemented because I am not a JavaScript guy. So here we have some JavaScript that would be embedded inside your site. Anybody see any problems with this?
Look good.
That was the fastest analysis ever.
Oh, there it is.
I'm looking for it. Anybody sees the problem, let me know. I'm assuming there's a problem here.
I'll tell you if you can't find it.
You got your hand up, go for it.
Is it that user could be an HTML tag because there's a break symbol right there, so somebody could import HTML that loads something else?
User is getting directly
user's
appended
putting out
to
the
the
document.
HTML tags as one giant cohesive string without any separation of user input and the HTML string that this function is directly returning to be executed by the browser.
So you're saying there's some sort of escaping of user input that is not being done here?
Is not being done.
Why is that bad?
Your username could be a script tag.
What would that do to me?
It would execute arbitrary code on your machine.
Who thinks that sounds bad?
What if it's nice code?
What if it's nice code? What if it's the code that gets rid of all the ads on my webpage? That might be nice.
It's the FBI shutting down the botnet for
But
you.
I did all the expensive logic in the user side JavaScript so that their computer would pay the price, not our servers.
So taking user input unfettered and just using it somewhere, generally a bad idea. So in this case, yes, getting user input and then blindly using it without preventing any badness that was in there good old Bobby tables. Anybody know Bobby tables?
Oh yeah.
What's Bobby tables? Someone?
SQL injection.
SQL injection made notorious because of.
If you if you make your name a SQL query, then you run the SQL with the name, or the query can be anything you want. It'll just run. It'll be like the ability to drop all your tables.
So there's
semicolon and then.
So
put
there's
the
a-
other put other SQL statements, and you make it do SQL statements.
You could pull it up.
I do not trust myself to open a web browser
Oh, fair enough.
on a presentation machine.
It's not very secure to open a web browser.
Oh my god. There's an XKCD for everything. There's an XKCD where, you know, what happens? The parents get called because the kid was doing something bad at school, and they said, "Oh yeah, good old Bobby tables," because he said insert, you know, name Bobby semicolon delete.
And when little Bobby Tables grew up, he registered a company in the UK. Drop Table Companies Ltd.
There we go. Thank you.
I have the link if you want the URL.
Which XKCD is it by number?
Oh no, that wasn't an XKCD. That's a thing that actually happened to the UK Business Register.
Oh wait, that was real.
Yes.
Oh no.
I'm not making that one up.
Oh, that's even
I don't
worse.
think it actually damaged it.
No,
But
but
they
they got it
registered
registered as a name.
Yes.
I don't believe it did damage. But
Okay, back to our presentation. Here was where we had a bug. We are just blindly taking the user and appending some HTML. This is how we would clean it up. We take that user, the user variable that came from elements, we use DOM urify.sanitize. We're actually sanitizing and making it valid HTML. So if I have an ampersand in there, it turns into ampersand AMP semicolon. This will prevent any of this stuff that was HTML from turning into, you know, executable script.
Would you like an addition?
By all means.
So if you're writing code like this, it is incredibly tempting to say, you know what, all these sanitization libraries, they're complicated. I will just write my own thing, and all it'll do is it'll encode everything, it's fine, I'll write it myself, it'll be perfect. Don't do that, that's how I have a job. If there is a professional library for a security thing like that, use it.
I have a minor addition. For anyone not familiar with HTML and JavaScript, it might not immediately be obvious how arbitrary code execution executes to the exfiltration of cookies if we haven't discussed in detail how cross-site origin restrictions work. It could be as simple as having that script tag that we put into the username execute a GET request, or even just a GET request to a URL with a parameter containing the value of the cookie. So even if the domain is not the one that we're on, you can exfiltrate data through arbitrary code execution, which is probably obvious, but good to explicitly complete the mechanism of attack.
Awesome. Again, anyone wants to break in with cool ideas, bring them up. So, as we're trying to defensively write our application, what can be done? First and foremost, please validate and please sanitize your input. Don't throw Bobby tables in there without making sure that it's valid. When you're outputting stuff, make sure that it's in the right encoding. If you're UTF-8 versus HTML versus something else, make sure you're doing it valid. I remember my very first time I was making a little online forum thing. It didn't sanitize my own output. I'm like, how come everything was bad? Didn't even think about the fact it could be a security bug down the road. You know, you've got to sanitize your own output. Content security policy. Content security policies are headers that you can put inside your HTTP responses that give information to the browser about what you can or can't do. There are several web pages that will help you develop them because they are not intuitive, I would say, to create those yourself. Use security headers. You can actually put in, like say on a cookie, you can say, you know, this is a secure cookie, or it's an HTTP only cookie, which would make sure that that cookie only comes out if it's HTTPS, or for HTTP only would never come out from other protocols. So you can actually, for a lot of HTTP headers, put in security headers that will help the browser do the right thing.
Secure coding?
What's that?
Are you looking for secure coding?
Nope, I'm the tech chair. Sorry to interrupt.
We got time. And of course, escape your user inputs that goes along with sanitization. Okay.
Oh, that's fun.
Would you like to take this slide? I haven't looked at it yet.
It's mostly that this is not what I expected to come up in this talk.
None of it's what I've expected.
Basically, this is not something I'm an expert in. You can take it if you're familiar.
I haven't read the slide yet.
I think this one relates to something similar where you once you submit like a form and you expect that value to be rendered into a template later. So a server-side rendering framework that takes a value and then renders it in. You can do something similar where instead of a name, you give it a script tag and then it would render that on the on the page, which if other people load that page with that value in it, it can go pretty far instead of just being restricted.
I don't think it's as, well, I guess it is if other people load the page, but it's like putting Jinja into your user bio. It executes on the server side as the template is rendered server side.
Yeah,
So,
so-
before it's distributed to clients, although it might not be rendered until a client requests the page.
Yeah, so let's say, who's seen Ginger 2 templates before? I know you have. So they're like double, curly brackets and then something. It's usually, double curly bracket name. And you'll have, I'm the developer. I've written a page here. It's got, a bunch of HTML and a bunch of curly brackets with variables in them. You can even have like for loops and other, actual logic inside there. And that is easy for me as a developer to more or less program my output without having a whole bunch of string concatenations. Here's the beginning, and then I replace a name. And another string, another replacement over and over and over again. Those templates make it faster for me to develop. And as long as the data I get from my users is not going to look like more template language, then it's fine. But if, Bobby Tables, if you will, includes as part of his username, double curly server IP address, double curly, or some other variable, super API key. What they could do is they could give you data that will be replaced by Jinja or whatever your templating language is with the actual internal guts of the system. And so you'd be able to get information about what the API key is, whatever variables it has access to.
A fun thing about any kind of server-side attack is like if you mess up and put cross-site scripting on your website, the worst that will happen is all of your users' data will get stolen. If you mess up with something server-side, the worst that will happen is you give an attacker a pivot point and they can run rampant around your network, because now they could basically do anything that server-side templating language lets them execute on that box, such as opening a port, allowing an SSH connection, things like that.
And mapping their X.
And mapping, yeah. That's step 2.
So let's look at some sample bad code. Anyone know what language this is?
Python.
Come on, Python.
Yeah, that looks like
Specifically, what do we think they're using for a framework?
Django.
Looks like Django.
Doesn't that make my Jinja mention apt?
I think it does. So you got a Django piece of code here. You got a route. When somebody comes to /profile, this is what's going to get called. It'll be called if it's post or get. It won't be called if it's on a head request, for example. So in this profile, we figure out, is this a post or a get? We grab the username from the form that was sent to us. So it's doing all the magic parsing for us. Like we love using libraries, as you were mentioning before. Don't rebuild this yourself. Use the things that work well and have been well tested. So we grab that into name. Then we got some sort of login.html. It's the first line after the break. There's a login HTML file on the hard drive inside the source code. And it is the login page. It looks great. It's going to just replace the name with whatever the person's name is. As this is, since we've done no sanitization on the name, if there are more Jinja codes inside name, when it does the render, badness can happen. So
I actually am not 100% certain about this.
It might be a single pass render.
I'd say it looks like it's actually a double render. It renders the template and then it renders it again.
Oh, there we go.
So that's where I think that's where the error comes in. It's doing a double render.
that makes more sense.
Otherwise, the name is automatically sanitized.
Yeah, you're right. Since it was sent as positional for keyword arguments, it would be clean the first time.
Yeah, I think so. But the second render template string,
Why are they doing that?
it is not clear to me.
Because they
I've
want a good
definitely
example.
written worse code.
I have also written worse code. So let's see what we got here.
Yeah, just render.
Yeah, this one says just do it once. And apparently we've screwed up all of the indentation. So don't double render unless you don't escape it. What can be done? Doesn't this first bullet point look like one we had just a couple pages ago?
I've never heard the term auto-escaping.
Auto-escaping is when you have locked yourself in the car. I don't know what auto-escaping is either.
Some language, some frameworks like I want to say like React and them will by default escape everything that you like try to output to your template, and you have to explicitly like opt in to say no, this is HTML safe, I pretty promise, or maybe I have tags in it on purpose.
So on every time you do that output, you have a specific flag to say do not auto escape.
Yeah, you have to call a specific function or annotate it in some way. I don't remember the specific mechanics, but some frameworks by default just escape everything because they don't trust you, as they shouldn't.
Okay. Don't actually convert this to sanitize this code coming out.
I do think the most important thing is to know what your tool does. If it auto escapes, that's great, but you're going to have exceptions where you want it not to.
Right.
If it doesn't auto escape, you have to know that it doesn't. You need to escape yourself. Make sure you really understand your framework so that you use it the way it's meant to be used and don't get surprised.
Such as if you put like special characters in your password, you have password field, and it like sanitizes that. That's not your password. It won't work.
That is also true. So understand escaping, what your framework gives you, and make sure that you're using it properly. Content security policy, again, those headers we talked about earlier on. And this last one, regular security audits. This should happen as you're doing merge requests with your friends, with your coworkers, but you really should look at your code more often than just when the new change is coming in. If you can have a security group or security team, or maybe just every Thursday, first Thursday of the quarter, everyone just looks around for security holes and problems. Find ways to go and re-look at stuff that was in there. LFI, local file inclusion. Most systems have some sort of file system. That login.html file before was on the hard drive somewhere. It is possible with badly written code for those files to be escapable through your web interface. I can't see that because your head's in the way. Include languages ///restricted.php.
So this would be like the user edits the source code or opens the browser console or something and just does more requests?
No, I mean it could just be in the URL bar even. You
Oh,
can try doing the ... and see if it lets you out of the site's root, which I can't imagine is default for any web server.
These days.
Don't write your own, okay, maybe do write your own web server, not in production.
Wait, what? Write your own web server?
Yeah, you can make it the default.
Do
what you
do it for
want.
fun. What's the worst that could happen?
I think we've seen the worst that can happen every time we do that. Let's take a look at an example. So here's some PHP. Don't write in PHP. No, that's just me.
You're right though.
It's very opinionated, and I shouldn't have said that. But I really feel it. So here's some PHP code. We're going to get a variable called file. We're going to grab from the page value that came from the end user. So that is user-supplied input. If it is set, then we're going to go and grab the file contents and just dump it out. Maybe we shouldn't do that, because what kind of value would they for page? Presumably, you're doing posts or you're putting in URL parameters, so you know for a fact, you, the author, know for a fact it's going to be one of the 5 templates that I need to put out there. But if it is user-supplied data, even if it's in a post that you can't see, somebody who's running Burp Suite or looking through, the Chrome debugger, they're going to see what the actual parameters are. They're going to see, oh, there's a thing called page. And rather than cart page and welcome page and about page, they're going to say ... ///Etsy/password. And then this is going to blindly grab that and put that in the H3.
Well, hopefully it doesn't have permission to do that, but...
Etsy password is open and readable. Etsy shadow, hopefully.
Oh, you're right.
But, any file that you can get out there, maybe they look to see, a Debian version. Oh, now they at least know it's a Debian machine. So they can have specific tags for Debian.
Etsy crypt tab.
Ooh, yeah, even worse. So here we have a way of trying to figure out, is this a valid page? So what they've got is a regular expression. Who knows the regular expressions are things? Who loves regular expressions? Who still writes in Perl? My apologies to all the people whose hands were still up. Regular expressions are extremely powerful. They are your friends if you know what you're doing. They are your enemy if you think you know what you're doing. This is actually using some pretty decent regex here. I'm going to walk through it. So in this case, / starts and / ends. The caret, first character, that means anchor at the beginning of the string. So we're essentially taking that file name they gave us, we're trying to make sure that's right. So at the very, very beginning of the string, and then we've got these brackets. So this is a character class. It matches any one character from the stuff that's inside it. The stuff that's inside it is capital letters, A through Z, lowercase letters, A through Z, 0 through 9, and the character dot. So it's looking to say, is this any one of these explicit characters? At the end, and if I had just from that, it would match any letter up or down or whatever, with a plus after the end of it, after that bracket, means one or more. So this matches any number of A through Z, 0 through 9 dot. So foo.exe would match. The $ at the end means the entirety of this thing needs to match. So don't stop halfway through when you find a failure. Continue all the way and make sure the whole thing matches. In this case, the most important thing is slash is not allowed. Since slash is not allowed, you can't do .. // at C crypt tab.
What about
Anybody have
%2f?
What's that?
%2f.
%2f is the ASCII character for slash. But when you try to open it, it's going to be looking explicitly for %2f as the file name. So you should be okay. But then again, I'm not a PHP expert. That would have to be where you really understand your framework.
But also percent's not allowed in that regex.
And %'s not allowed in that regex.
I was gonna say, well, maybe your file system resolves it, but it'd be fairly exotic.
Yeah.
So this is how this person decided to solve the problem, is by doing a regex. Anybody have ways that they would do it that would be different?
chroot, AppArmor, namespaces, anything.
We went very far. Okay, I'm going to do this one at a time. Chroot. So that would be making this run inside a separate root environment that doesn't have /etc. It's a way of making your program run chrooted, changed root, inside a smaller portion of your file system. You had like 4 things in your app. Big
AppArmor?
AppArmor is a way that you can tell the kernel different programs can only receive certain files. You can protect out those so they can't see it. Keep going.
File system namespaces, which is your.
It's similar where you make it so you can only see different versions of the file system.
I ran out of things.
That's cool. It's a great list.
What I would do as a programmer is I would have a hash table that showed the list of all the valid file names that I'm allowed to echo and never echo anything that's not on that list.
That's the way I would go.
Yeah, okay.
Because then you can see inside your code what is allowed. Rather than this says, we're going to get rid of the bad things and only pick the things that are probably fine. Well, you wrote the frickin' code. You probably know which things are allowed. And while you're debugging it, if you hit one that you want to work and it's not in your list, it won't work. And you'll be like, oh, I need to add that to my acceptable list.
I have a thing.
Yeah.
Someone might think, well, what if it's very dynamic? Well, let's say you have a page for every user. You could confirm that the input matches a user and then load the page with, say, user.html.
There you go.
So validate the data.
Yeah, so this is much better than the previous one, which willy-nilly grabbed files. But you can do any of the things we just suggested.
Imagine that would also not work very well if someone made a symlink in that folder that went to another part of the, like went to /root or.
I suppose that's escalation. They would need to be able to make the symlink, but valid.
Yeah, symlinks, for those who don't know, a symbolic link is it's kind of like an alias. You have a file, which is a symbolic link, and it does not have the content of a file. It points to a different name. You make it with an ln minus s, ln like ling, ln minus s, actual file space, new name I want. If you try to read, write, delete that new name, it'll be looking at the original one. If you delete it, it gets rid of the symlink. If you, open, read, write, it writes to the real file.
And this wouldn't survive a chroot or any of our other suggested options.
Correct. What can be done? Has anybody seen, say, input validation on any of these slides? Could it be that this is one of the most important things for us to do? Why, yes. Allow listing, I will just make a little change to that word there. Allow listing. Rather than saying, here's the bad stuff, try to say, here's the good stuff. If we've got a list of good, that's better than saying, well, here's a list of bad. Because you can never quite predict what bad looks like, but you can be anal retentive of what good looks like. Path names, try to make sure that you're working off of the known places you want your content to be.
You could resolve the provided path to an absolute path and then check the prefix to see if it's in your directory, because the .. / won't survive a resolution to an absolute path name. This still might not be the best solution, but it's an approach.
Yeah, RealPath is a wonderful tool that will resolve the actual thing, no matter how many layers of symlinks you've got. They'll say, here's the actual version of the file name. Like from the hard drive, this is how you get to the actual line. Canonicalized, thank you. Access controls, least priv, security scanning. Actually, what is least privileges? Anybody know that one?
Don't use an admin account for everything.
Don't use an admin account for everything. Give access to the thing only what it needs to do its job. For example, if you've got a SQL server you're talking to and you got to read a bunch of data, make it a read-only account. Make it have read-only to only the tables that it needs. Don't give it read-write. Certainly don't give it admin access. So least privilege can really save your bacon. Like if there is a bug and your password goes out there, Bobby tables can only read all of the Bitcoin.
Say goodbye to your bacon.
What's that?
Say goodbye to your bacon.
Say goodbye to your bacon. File uploads. Oh boy, you're taking user content that's even bigger this time. Anything that is taking uploads in data we had before is differently when you got files. So let's find an example. So in this case, looks like we're PHP again, my favorite. Getting the upload. Now when you do an upload, it gives you the file name that the client sent you. For example, foo.tgz or whatever, and it also gets the file content separately. So I believe, yes, the fourth line down, target file equals target dir.base name file name. That is the name that came from the client. So I called it foo.tar, say. In this case, we are taking the name that the user supplied. Anyone feel like that's bad? I feel like we all think that's bad.
Yep.
And it's using that to generate the file name. Who can think of an attack?
You could have another arbitrary code execution exploit.
This should be just making the file name.
Oh.
You make the file name dev null.
Here, /////.
//
Override
How about
executable.
Apache config?
Overwrite an executable.
How about Apache config?
Overwrite the Apache config, which hopefully
just override
is only
Apache
done by
config.
root, but you never know. But if you can overwrite an arbitrary file, maybe you're overwriting an executable. Maybe you're uploading your new version of this PHP page, right? Maybe the web root is owned by the same person who's running the web content. So you could change the source code for this PHP page. You could be, making the, the version of true now be your own, elf file. They do try to figure out the type of it and say, if it's PNG, then, yes or no.
But they trust the user's word for it instead of actually checking it.
But they're trusting the user. And, users should never trust users. Users' mistakes, aren't just generic mistakes, and they could be malicious. So here's a prettier, more secure version of that.
Base name.
Base name takes whatever the string you gave, like .. // blah, and we'll convert it to just blah, the last thing. Base name is a good way of getting rid of all the path info. So they're trying to find just what the original thing was, foo.text. Has anybody thought? Oh, go ahead.
A general suggestion is there are so many ways to mess up your security when you're allowing file uploads that I could not list all of them and I have not found or tested all of them, but there are so many. And if someone says this is a secure file upload, chances are they just haven't had a dedicated enough hacker look at it. So really, if you can, just put it on a different subdomain, put it on a different server, treat everything there as probably a little suspect.
Inject it into a database. Just like, hey, I'm going to take the stream. It's going to be a string in the database. So
Yeah.
Yeah.
It's very common to have a user asset subdomain, and you're probably familiar with seeing that in your URL bar if you've ever viewed somebody's profile picture, for instance.
Something user content.
Get that user content.
Put it in an S3 bucket if you have money.
Put it in someone else's S3 bucket if you don't have money. Surely there's something open.
Could you just name the file a username and then the date and time?
You could.
Then they can predict the name of their file, and then they can do more nonsense.
Yeah.
Oh, I'd hope the username would be limited though to characters.
You can.
Random GUID is much better if you have to.
But also don't forget, let's say you're just putting the files on the web server, or you're putting them on the SMB mounted backend file server. People are apparently uploading stuff arbitrarily. They'll fill your disk. They'll fill. What do you think they'll fill it with? 4 letters long, starts with P, ends with orn.
Tweets were assigned sequential IDs, and there are some tweets out there that quote themselves by guessing their own IDs before posting.
Wait, what?
Say that again.
tweets have sequential IDs. So if you look at
Yeah.
the latest tweet, or just keep incrementing the ID until you hit the latest valid tweet, and then guess the next one and post at just the right time, you can quote yourself.
I bet you that there is
Or at
not an
least you
open
could.
bug to fix that.
Like quote a tweet you haven't posted yet.
Absolutely.
Yeah, I like it.
And then hope that you land on the right ID so the quote actually points to yourself.
Winning.
Could I quote something from like a year from now? Just
Yeah.
so random.
That bug
Yeah,
was
but-
fixed about 5 years ago.
That wouldn't be quite as much fun.
Yeah, sorry.
I'm sorry to hear that.
But the tweets still exist, right?
Yes, the tweet still exists.
As
They
long as
didn't
the
delete
domain
them.
is still working.
But you can't do that anymore. They don't. The tweet IDs are not incremented.
And they might depreciate the Twitter domain.
Yeah, you can try it. Yeah, yeah.
Excellent.
Okay, so continuing on. Validate. You know, size limits if you're doing uploads. Please don't fill your disk. Machines don't like it when that happens. Generate unique file names like was said over here. Don't let them pick it. Make it a GUID. When you return the file, let's say there's a download capability after the fact. When you give them the new file, you can return it back in the web browser with whatever name you decide you want it to be. So you, the programmer, can say that this is foo.txt, even if the real file name is 28-letter long GUID. Authentication authorization, just don't allow generic upload and download without authentication of some kind. Most frameworks support it pretty easily. Use a dedicated directory for those files that are coming in. Make sure it's outside your web root. Maybe make it as part of your backend SMB stack or something, or maybe stick it in a database. Conclusion. That is the end of our talk. Q&A.
Good job.
We got 6 minutes.
Room 1. Tell us about your dogs.
Oh, tell us about my dog. Hold on, I forgot what they look like.
I think there were 3.
How do I get to the beginning?
They had flowers around them.
Oh my god, this is so slow. My dogs, I think if I remember right, I have 3 dogs. I think they are Huey, Louie, and Dewey.
I would be willing to bet you have an Instagram with your dogs.
I bet you I have an Instagram with my dogs.
Bobby tables,
Bobby tables, Bobby tables.
How is this so slow to go backwards?
It's not just a PowerPoint presentation or whatever. It's also built into Streamer for our streaming services here. So there's some magic.
You
ones.
don't really
Okay,
know
so I need names for each one of these dogs. Taking votes for names.
Jared.
Jared and
Grenade.
Grenade. Grenade.
Don't lose them at the airport.
Oh my god.
Script, alert, quote, dog.
Those are the names of my dogs. I've had them for 3 years. It's really confusing at the dog park, and I did get strip search at TSA with Grenade. Next time I'm putting him onto the plane.
Next time name him Shark, but don't lose him at the beach.
Don't lose Shark at the beach. Any other questions?
What do you do as a job? You're clearly an expert in this.
I am actually between jobs right now, but I'm a geek, just like I think most of the people in this room are. I would like to really thank everybody in the room here. This was great. This was fun. You all made this thing work. I'd also like to express a lot of appreciation for Gopika who gave us this fine content. I'm sure it would have come out a lot cleaner if they were able to give their presentation. I'm really sorry that they weren't here to be part of it. But thank you for SeaGL 2023!
It's a strong game of whose slide is it anyway?
That's such a great idea. Whose slide is it? Yeah.
The original work.
Thank you.
I've seen that. I've seen where
You were an expert at
I mean, it's novel.
the game with random slides.
Oh, God.
That you had to present. I was trying to
Yeah, he would he would create like a slide deck of 10 slides. On each slide. Yeah, he would. They actually put that
Different.
Huge.
Yeah.
Yeah, I
Surf. is
You
when
know,
you have
the
a
ones that you
website
attended, I did
and
really
in
well.
your
I
and
definitely
you
really
can
nice.
browse to say bank.com.
Yeah.
And while you have
Yeah.
bank.com open and your cookies active, a different website you have open in a different tab, evil.com, sends requests to bank.com using your cookies.
I've never done
And it
that.
doesn't necessarily form JavaScript, it is just
It could be like
you
a post or a get request that has an actual action in like an image tag or
Yes.
something.
So what do I
like
wanna
a
do?
forum or something.
And bank.com says, well, certainly, this must be legitimate because you've got the bank open in your tab. The fact that
You
it's
wanna double check
evil.com
make sure
sending
that
you the
shows
request
up
must
for
mean
you.
it's perfectly safe to send all your money to evil.com. And so
And
there are a lot of protections against CSRF nowadays that can be summed up by use like, what's it called? There's protections, I think special origin policy is one of them. Use modern tools is the summary.
Yes, and what is the what is the cross-origin policy exactly?
It's one of the things where you have to explain it 3 times to understand it, and I haven't looked at it in a couple weeks. But in
I don't do websites.
in short, what it is I might be using the wrong term, but in principle, what it is if I'm a website, if I'm getting a request from another website, I check to see if that website is allowed to send me a request. So if I am bank.com, I'm only allowed to receive requests from subsidiary.bank.com and accounts.bank.com. If evil.com tries to tell me anything, no matter how legit it is, I don't like or trust evil.com. So even if evil.com says, hey, send me your cookies, I will say no. CSRF. Cross-site request forgery.
So in the example case of like somebody posted like a withdraw link on like a forum or something, the browser automatically loaded it.
So that would be that type of attack would probably be an XSS because you don't use the link for CSRF.
Could show up here in 10
CSRF
minutes.
happens with having the evil website open.
That'll be so bad.
I see. I thought CSRF didn't require an evil website, just an evil user posting content to a
That's assuming
third-party
that
website.
That is cross-site scripting.
That doesn't mean scripting though.
Cross-site scripting, I don't
No,
know
not
why
me. I
it's called
team
what it
has
is.
room one
Cross-site
way.
scripting
How is
is,
everybody?
I'm doing nonsense along the lines of putting my code where it's not supposed to be in your website. My code will execute in a circumstance where it's not supposed to be.
It doesn't necessarily have to be actual executable code.
Do you have Jeff Silverman?
There's one type of cross-site
either way,
scripting called
this needs to be rearranged.
self-XSS, where you can hack
This
yourself
gets unplugged here.
and nobody else.
Gets plugged
But
in
that's
there.
still a problem
This goes to
because
the
it
presenter's
indicates bad
laptop.
security practices. The other
OBS.
types
Switch is scene.
The other types are things like the URL.
Do I need my
Wait, hang on. Okay, there, that's working. Great.
Oh,
we need to find Jeff Silverman.
Okay.
Jeff? Yes. Okay, you have a laptop? Come plug it in. You're standing over here, not over there. That would be too convenient.
That's the room 1.
Which talk is this one?
For you. This is Jeff's talk about what's really going on when you use your browser to access something on the web. The other room.
This one also features the OSI model.
You have HDMI?
Yes.
Great.
It's back there somewhere.
Yeah.
Get the power supply.
Sorry.
This is about an order of magnitude more people than I was expecting.
That's a good problem to have.
No, it's not. My bladder has only so much capacity.
Hey, look at that. It just works. Perfect.
Yeah.
All right, great. We're going to start the recording. This is live. Whatever you send this onto the projector is live on the internet.
Okay.
Here, do you want me to unwrap this for you?
Please.
All right. I'm sorry. You're good. There you go. You are. What did you just? What happened?
I mean, what just happened?
Um.
I just plugged my mouse into the USB port.
Yeah, no, I'm
and clicked
talking.
on it.
Here. Whatever that was. Don't do that.
Okay.
Not you. Sorry, Jeff. You're fine. You're doing everything right.
That was a what did I do, not what did you do.
Okay. Yep. You are displaying onto the main screen there. You just have a black background is all. But I did see your mouse move just a minute ago. No.
I don't think so.
No. What was the question?
Which topic is this?
This is Jeff Silverman. What's really going on when you use your web browser to access?
That's what they said was the other room.
Yep.
No, that's this one. This is Jeff.
They did a switch.
Okay.
A little bit of switch.
Undocumented switch, and what they. Yeah.
What guides? The web page or this?
The web page.
Okay, so it was supposed to be this, and then it became wrong, and so it became what was on the door. But then it was going to be the web page, but then OSM broke a bunch of stuff. So OSM is also wrong. Just go to a room and ask what talk it is the best way to do it. I'm sorry.
No, thank you.
What talk is this?
All right, are you? Oh, you.
We're still having confusion over.
Okay, there's an
This
SSID.
was supposed to be room 3, and that was supposed to be room 2.
I connected up earlier today.
Every talk is like, is this? Oh, we're in that room, but it says on the tag, it says.
We'll have
pay
it
attention
fixed
to this.
tomorrow. Tomorrow, all of the rooms will be right. University of Washington. Do you have the login prints?
Yes, I do. At
Okay.
least I did. But there. Connection established. And it's thinking about it.
Do you have this?
This actually be.
Okay, thank you. I'm gonna run to the next room and see if AJ needs help in there. This is working fine. This is going to the internet. This needs internet.
Yep.
There might be. There's no Ethernet in there.
Is this live right now?
Yes, that's live and it's recording.
Okay.
Okay. Thank you.
All right. So this is a golden opportunity to discuss what goes wrong when with your network. And actually, this is a presentation that I gave a year ago. So first thing you have to do is turn off the caps lock. So then you have to spell link properly. All right. And so you can tell from here that my wireless is up and running. All right. So that's good.
You weren't actually.
Beg your pardon?
You were on that screen, but you're not. I'm not seeing you on that screen now.
I'm just wondering.
So the
I always have this misgiving when I go push buttons and I don't know what I mean. There's got to be a light switch around here. All this technology. I don't think I want to put that push that button. Oh, what about no? That says Windows. Do you have one of these buttons that says Linux? All right. Well,
It was very visible when you first.
Right.
What?
How do we see the displays connected? Is this? Are you using HDMI or display?
Oh,
yeah,
you
display
might you might unplug and replug the maybe it will fix itself.
Well, this is a Windows machine. I try rebooting, but
So which it shows a
Is that
separate
get display outline
panel over
from
there,
the
like the touchscreen setting.
It's not because that hasn't changed.
No, it's display. Display.
If you go to the control panel under display, does it show the HDMI display as well?
Is it detecting a second display?
That's where we're going now. It'll be under the hardware section or
no, it's
display
under
section.
monitor section.
Monitor settings, sure.
Okay.
HDMI. So it's set to extended. So do we want to duplicate this?
Let's try it.
Not much in terms of options.
Do we have Wi-Fi in here? It's not Wi-Fi, it's display. Display was fine just a minute ago. I saw his mouse move.
Did that like get unplugged maybe?
Can you move your mouse to the?
Yeah, I think it's just
opposite one?
extended.
Yeah, so there, see?
Yeah.
There,
So
you're,
you just
you're right
need to
there.
drag
You're,
your,
Oh,
the window that
okay.
you want to display
Okay, so
off the screen,
There you
as
go.
if you have a
You're right there.
second monitor.
Do we need to reset
Yeah.
the scale?
So
No, it's
no,
fine.
no, it's
Okay.
perfect.
Okay.
close
Just-
all that and get back to what you were doing.
okay.
No.
There you go. Just go to your slideshow.
Okay, you don't need to change any of this
Yep.
anymore. We can
No,
just
none of
close
this
all
needs
this.
to be changed.
Yeah.
So all you have to do is take the window that you want and drag it over to there. Or do you have a slideshow?
Does that make sense?
That makes sense.
All right.
All right. Great. Thank you so much, Jeff.
Thank you. All right. It's still thinking about it. So this says I'm connected.
I believe in you, Google.
Okay. So now, if memory serves me, that is event 04.
It's one word though.
What?
It's 2 words on the screen, so you'll want to.
Zero 04. Okay, and the password? I beg your pardon?
It's a 3. It should be a 2.
This is going to be really hard on my neck because I have to start over there. Okay. And the password is
Capital L,
L.
Linux, Linux.
Uh-huh.
Capital C, conf.
It. There's an old saying, it is better to ask a question and perhaps be thought a fool than not to ask a question and remove all doubts in anyone's mind. So please, if I say something that you don't understand, stop me at the moment. And hopefully I will talk fast enough that it'll be about 30 minutes for questions and answers after the talk is over. All right, so here's the outline of the lecture. I'm going, I don't really have to read this to you, but basically there is kind of a list of things that you really ought to understand, except you don't need to understand them. I was chatting with a 7-year-old kid earlier today about browsers, and his first question was, well, what's a browser? Well, in fact, he's been using browsers all of his life, and he didn't know it. So, and that's actually kind of the way things really ought to be. You ought to be able to use a computer without having to understand it. I've got a 2-year-old son who is very computer literate, and I'm still teaching him how to count to 2. He counts to 10 just fine, but 2 is problematic for him. And once he gets to 2, then maybe I'll get to 3. And actually, maybe he'll get to 3 before I do. But anyway, that's a different problem. And this is actually the wrong view. This is the edit view, and I want the presentation view.
Slideshow button in the top right.
Slideshow button, top right.
Oh, 2 over. Share slideshow, yeah.
That looks better. So, I was been developing this thing until very early in the morning this morning, and so that's why it looks more normal to me in edit mode. All right. So, there are 3 kind of critical acronyms that you should know that begin with the letter U and actually begin with UR. And they're very, very confusing because people use them in non-standard ways. So there is a uniform resource identifier which just identifies a resource on the network somewhere. And it doesn't tell you how to get to it, it just is. And the problem is that if you don't know where something is or how to get to it, it's of no value to you, which is why you don't see these things very often. So Jeff Silverman is a universal resource, but you have no idea how to get to where I am. I might be at my house, I might be at work, I might be here. You have no idea. And you have no idea if you can get there by walking, by riding a bus, by flying an airplane. Not very helpful, which is why you don't see much about them. The uniform resource name is more ambiguous. It describes or it identifies a resource, but again, it doesn't describe how to access it. The difference is that URIs are not ambiguous, but URNs can be ambiguous. So there's a Jeff Silverman right here. There's another Jeff Silverman who happens to be a computer expert in St. Louis, Missouri. And so that's an example of 2 different, the names are the same, but the way you access it is different. So he's got a different URL, which is not only a resource, but also a scheme. So he goes to whatever his website is. If you want to talk to me, you go to jeffsilverman.ddns.net or jeffsilverm@gmail.com. Those are unambiguous because they're unambiguous. They've got to be unambiguous because otherwise people would get confused between the 2 of us, which happens all the time anyway. The URL, in addition to being the resource, it describes how to access it. And there are a couple of dozen schemes to access resources on the internet, most of which browsers don't use. But if you think about a browser as being a special case of a HTTP client or actually a client of any sort of TCP/IP protocol, then that begins to make a little bit more sense. So the schemes are kept track of by IANA, and if you come up with another way, another scheme of accessing resources on the internet, you send an email message to IANA, and they will give it to you. Now, in this presentation, I'm just going to cover HTTP, HTTPS, file, and mail to, and I'm going to touch on SSH very briefly just because Git uses it. You're familiar. I'm sure that you're familiar with HTTP, which is Hypertext Transmission Text Protocol. And there's also HTTPS, which is Hypertext Transport Protocol with security. I assume everybody here is familiar with that because this is what Tim Berners-Lee came up with decades ago. Actually, HTTPS came later, but and then mail to is a scheme that you can use for sending an email message right out of your browser if your browser supports it. Some browsers do, some browsers don't. SSH is the underlying protocol for Git, which is a configuration management system, and SFTP is also built on top of it. So again, there are dozens of other schemes, and there's the URL for it. So some of these are recognized as URLs by Google's slide, and some of them are not. So it doesn't recognize file as being a URL, but it is. And if you were logged in on my computer and you use that URL, you would get to my home directory. And but anywhere on the planet, if you want to get to my website, there are two URLs for it. The first one is not secure, and the second one is secure. And then the fourth URL is how you can send an email message to somebody from a web page. So in this case, this is an excerpt from a web page, and it's got the underlying text of how to send me a mail message. And if I get a mail message that says somebody copied this URL, I'll know that somebody copied and pasted it into a web page somewhere and then clicked on it. And then the last one is a URL from my Git configuration file, and it describes how to get to my Flask repository from the directory that I've got my local repository in. So it's working over SSH, and you can't tell by looking at it, but it happens to be that I'm using no password authentication. So in other words, I've got my local public key entered into the authorized keys file on the Git account on Raspberry. And the fact that I have my private key that matches the public key proves to the Git repository that I am who I claim I am. And the reason why that works is because that private key is private. So only I can have it. And that solves the problem of authentication. And I guess it also solves the problem of identification. I guess I haven't really thought about that until I stood up here thinking about it. So, but it just works, and it's really secure. And this is the preferred way of accessing repositories these days. Now, one of the things that I see every once in a while in a URL, and whenever I see it, I think, here's a computer expert who should be shot. Don't put a username and path. Well, okay, if Donald Trump say we can murder his best general officer, I can say the computer experts ought to be shot. It's the same thing. So anyway, do not use a username or a password in a URL. Passwords are supposed to be kept secret, and if you put them in a URL, by definition, the whole world sees them. So that's why that's a really bad idea. And then the problem with usernames is that the usernames of things change all the time. So sometimes my username is Jeff, sometimes my username is Jeff S, sometimes my username is Jay Silverman, sometimes my user interface is Fatface. That was done by a system administrator who didn't like me. You know, usernames change. And then the password is an authenticator. So I'm the only person who knows what my password is, and I use OpenSSL to go generate random passwords. Does everybody know how to use OpenSSL to generate a random password? You don't know? Okay. Watch this. Okay, first of all, I got to find my mouse, and then I'm going to drag this over here, and then I type OpenSSL. It's all lowercase. OpenSSL, rand, and then base64 seems to work pretty well. There are some other options. How long a password would you like?
20.
20 it is. Okay, so there is a pseudo-random 20 character password, and OpenSSL uses what's called a cryptographically secure pseudo-random password generator. And try saying that 20 times when you're intoxicated. And interestingly enough, sometimes they come up with one of these, and the system that I'm sending it to won't accept it for one reason or another. So this one, were it not for the fact that it had that equal sign at the end, would not have any special characters in it. So in that case, If it doesn't work, you just up arrow and try it again. And this one will work because it's got a couple of slashes inside. Okay, so this is how I generate pseudo-random passwords. And so now with this kind of technology, you can go to Las Vegas and still lose your shirt. All right, so where's my mouse? There it is. So, oops. In an ideal world, authentication and authorization and auditing. I'm sorry, authorization is handled entirely by the server that you're accessing. Your username is your identifier. Your password is your authenticator. That tells the system at the other end that you really are who you claim you are. And then that system should authenticate you, authorize you to do certain things. So on my machine, I'm using sudo, and it authorizes me to become root. When my wife logs into my computer, it authorizes her to access just her directory and nothing else. That's as far as I trust her. We've been married 41 years. I've got a pretty good handle on her capabilities. And then this is instructions for user community. If you are authorized to access something and somebody else is not, don't give them your username and password. That is a big no-no. Instead, have them go to the proper authorities and have them either authorize that person or not authorize that person. If they don't want to authorize that person's got to go to management and say, look, I can't do my job because I need authorization to do this. And sometimes there are legitimate reasons for doing that. And then, that's close enough. So, the first part, let's see, wait a second, am I missing something? No, okay, so part of the, I think I blew past, did I blow past this slide? Okay, so I'm sorry. So a complete URL for HTTP and HTTPS has got the scheme, and then a colon and 2 slashes, and then optionally username and password separated by a colon. And then the @ indicates to the browser that what's on the left is a username password pair. If you don't have a username password pair, you don't put in the @. So then next comes the host, which can be either fully qualified, partially qualified, an IPv4 address or an IPv6 address. Then comes a colon and the port number. For HTTP, the standard is port 80, and it will default to that if you don't indicate it. And for HTTPS, the default number is 443, and you don't have to specify that if you don't need to. Now, later on in this presentation, if the gods of demonstration smiles on me, I'll be able to show you a URL that actually has a port number in it, and you can see the difference. So then next comes a path, which is a roadmap through an arbitrary file system. It may be a real file system at the server. It may be something that was created by the server software as a means of getting to a particular resource. You don't know, and it doesn't matter. All you need to do is know what the correct path is. Now, one of the genius parts of HTTP is the ability to have a query. So that's something that Tim Berners-Lee did not think of when he first dreamed up the internet. He was thinking about it entirely in terms of static content. And then someone said, well, could we figure out a way to do this dynamically? And this is what they figured out. And then finally, you can have a # and a resource. And that's commonly used when you have a bookmark. You can think of it as being a bookmark into an HTML page. Okay. Now, let me go back to where I was. Okay. Now, for the host, you should really do things in ASCII. And the anti-use case is those two letters are not the same letters. The first little o is a little o, but the second little o is actually a Greek character called omicron, and it is a perfectly legitimate UTF-8 letter, but just staring at the two of them, you have no idea which one is which. And I can see someone doing a great deal of mischief by having a UTF-8 character. Can anybody think of, for example, hijacking Microsoft.com with a UTF-8 character? It'd be a piece of cake, wouldn't it? And they could go register their URL with one of the certificate authorities, and you still would be able to tell the difference between Microsoft with an O and Microsoft with an Omicron. And so there's been a lot of debate within the IETF about that. You look like you have a question.
Yeah, what would the exploit be with using a UTF-8 character within a URL? Because like if I tell you Microsoft.com, you're obviously not going to type the Omicron as the O. So how would people end up visiting it?
So one example would be an email, and another example would be in a web page.
Okay. So you need a web page that like links to a malicious page.
Yes, but that's not hard to do these days. So have you ever taken out your cell phone and gone up to a QR code and taken a picture of it and then tap scan this and go there?
Probably usually after you scan it, it usually just goes there automatically. It doesn't show you what you're actually typing.
That's true.
Or what it has encoded.
So domain registrars actually stop this attack for the most part.
I'm sorry?
Domain registrars stop this attack for the most part. They have a set of characters that are valid for their particular domain registration and don't allow, like, you can't use mixed character sets essentially in most cases. Unfortunately, .com is one of the few exceptions where you can get away with pretty much anything. But if you're on like a Chinese, so Chinese have their own characters set, and they have domains that can use Chinese characters as their host or top level domain, and so that area will only accept Chinese characters in that area.
And in those, in that case, yes, it does work. But there are unscrupulous domain registrars. And there is a story, I don't know if this is true or not, but there was some criminal organization that became the registrar for a TLD. And that was a recipe for all kinds of mischief until they were shut down. I don't know if that's a true story or not. Beg your pardon?
It doesn't sound familiar to me, but
well, I mean, it certainly is within the realm of possibility. So there's a lot of evil going on around the internet, and I don't know. I've just become. I took a class in computing security, and the only thing I learned about it was I can't sleep at night anymore. But anyway, so I'm going to go into DNS in a little bit more detail in a moment, and so you can feed it an IPv4 address. You can feed it a locally known host, which you get out of the file from /etc/hosts. And that's if you want to do your own local testing. You can feed it an IPv4 address. And so this is an example of an IPv4 address that's been qualified with a port number. You can do it with an IPv6 address, and the way you can tell the difference is an IPv6 address is set off with square brackets. And then the neat thing about IPv6 addresses is that if you have a long string of zeros, which is common, you can skip them by using 2 colons adjacent to one another, which is a big help. And finally, there's an example where you can use an IPv4 address in an IPv6 address, and that's the syntax at the bottom, where all the high-level octets are 0, and then you've got 16 bits of 1, and then you have the IPv4 address, and you can use this really terrific syntax, and that way you can take your IPv4 infrastructure and expand it into IPv6 really, really easily. All right. So I want to talk a little bit about hosting and DNS. At one time, DNS was considered, the domain name system was considered the largest database in the world, and certainly it has worldwide scope to it because it is federated. So at the top, you have a couple of hundred top-level domains, or TLDs, and those are things like .com, .net, .us, .il, And then under those, you have subdomains. And so in my particular case, my top level domain is .net, and my subdomain is DDNS, which is a ISP. It is a name service provider. It stands for Dynamic Domain Name System, a name. So and then my host name is Jeff Silver M. And so when your program wants to come to my name server, it's got to call one of two subroutines. One is get host by name, which is obsolete because it only works with IPv4, and the other is get name info, which will never be obsolete because it can work with anything. Now, those will reference the /ITSI/hosts file, and if the name is in there, then it will return the address and you're done. But if it's not in there, then it gets more interesting. It goes to a name resolver, which is a subroutine within your computer. That subroutine then goes out on a fantastic voyage across the internet. So for most homes, their resolver is, DNS resolver, is on their router. And so the IP address for that is 192.168.0.1. And the reason for that is that most home routers use that address. That's the default IPv4 address for that whole network. And so then it's got to look up the name server for ddns.net. And if it can't find out what the name server is for DDNS, then it goes and queries the top level domain, which is .net. So then my DNS, my resolver is actually a machine called nf1.noip.com. NoIP is the name of the company. .com, well, it's a company, so it's in .com. So it goes to the name server NF1, and NF1 then knows that jeffsilverm.ddns.net is within it, and it returns the IP address that's in it. Now, if it doesn't know what .com is, it can go to one of the root resolvers, and there are, last time I looked, 13 top-level resolvers just for .com, because if anything went wrong, that would be a disaster. And those machines are actually duplicated within each router. So we're in no danger of all the top-level resolvers going down. And if we do, we'll just have to send postcards to one another through the U.S. mail. And there are people that actually worry about that kind of stuff, and I think, well, they should. The port number goes from the range of 1 to 665,535, and there are a whole bunch of ports that are well known, and you can get the list of them from a file called /ITSI/services. There's one in Windows somewhere, but I have no idea where. It's in there somewhere. If you are developing your own service or your own server, and you can use a well-known port, then do it. You're going to see in a moment that I'm using port 8081, and that's because I've got two servers on my two web servers on my little computer, and one of them is on the standard well-known port 80, and the other one is on 8081, and the reason why is because they're two fundamentally different programs, and they do things in very fundamentally different ways. In the TCP world, when you are creating a connection from one machine to another machine, the originating machine uses something called an ephemeral port, which is typically above 50,000 or 56,000 or something like that. And that port exists for as long as that connection exists. So the combination of source IP address, source port, destination IP, destination port uniquely describes a connection. So if I've got two machines, two programs on my source computer that are connecting to the same server, they will have two different ephemeral ports. So that's how the machine at the server knows how to get packets back to the program on my originating server. And that really becomes an issue when you've got a IP addresses that are private, like you have in your home, because from the point of view of the machines on the rest of the internet, all they see is your home's IP address. They don't see the IP addresses of any of the machines inside it. Next is the path, and in staring at this thing, I realized that maybe this isn't the best example, because here is where the parts of the path actually map to files in my directory tree. So this is some data that I took when I was in Philadelphia in September of 2021. And so I organized it by day, and then within those files, there are pictures and recordings and more information like that. But this is how a path can map to a file system if that's the way you want to do it. Now, for most of the things that you will do if you're web serving from a Linux machine, you'll have a directory in /var/www/html. Nginx, by default, puts it under /user/share for reasons I'm not sure I understand. If you put it there, then only the system administrator can go make changes to your website, unless you want to give root privileges to your webmaster, which is never a good idea. I know, no, I'm serious. I know what webmasters do, because I am one. And I know what system administrators do, because I am one. But most system administrators are not webmasters, and most webmasters are not system administrators. And thank God for the distinction, because otherwise the webmasters who think they're system administrators will get in there and they'll start messing things up. I have seen it any number of times. Just don't do it. Unless you're really, really good. And I assume that everybody in this room is really, really good, or else you wouldn't be here. So whenever things go right, I'm always kind of pleasantly surprised. And maybe that's because in my career as a system administrator, I generally encounter computers in a failure mode of one sort or another. When I walked in here and this thing didn't work, that's usually the case. Occasionally you'll see a status code of 200, and that means that the transaction went successfully. If it's 301 or 302, that means a redirection. One of them means a permanent redirection, which is never respected, and the other is a temporary direction, which is always respected. And because of the ways browsers do and don't pay attention to those things, you might as well use 301 and just move on. 400 are client-side failures, and the most common ones, I mean, you see these on billboards alongside the freeway, is 404, which means that the file is not found. But there's actually a couple of dozen of them that are actually used. My own personal favorite is status code 451, which is that the resource has been restricted by the local authorities. And I don't know how many of you are familiar with a work called Fahrenheit 451, which is a dystopian science fiction novel, and that's where it comes from. You see it, don't you?
Personally, like 419.
419, I have a teapot.
I have a teapot.
All right, so who says that geeks don't have a sense of humor? Actually, my wife does. But anyway, so queries is really where our bread is buttered. This is, I mean, Tim Berners-Lee was thinking in terms of static content, and that's because he had a library of text at CERN in Europe, and it was enormous, and he needed some way of indexing it and making it available all over the world. And he had a good idea, but he didn't think through some of the larger implications of it, and he had a conversation with some people, and they said, well, why don't we figure out a way to make it dynamic? So this is the way queries are. So I created a little demonstration website, which is on my server, jeffsilverm.ddns.net. It's connected to port 8081, and it's got two paths. One is I am, that sets my name, and the other is who am I, that queries my name. And so this is where I'm going to do the bravest thing I've done in the past couple of days. I'm going to go HTTP. And you can't see what I'm doing, but if I take my glasses off, I won't be able to see what I'm doing. So, okay. So, here goes the $3.47 question. Okay, well, so much for that one. Anyway,
Silver M?
beg your pardon?
Jeff Silver M?
Yeah, that's the way it's supposed to be. Oh, wait a second. I know why. Because that is set up for my testing. So when I'm finished testing, this actually, if you had done it on your machine, it still wouldn't work. Okay, well, that's one of the problems with working with Flask. So anyway, I will get it to work. It's basically a question of turning Flask on, and for reasons I'm not sure I understand, it stops working. And it has something to do with the interaction between Flask and systemctl. And I'm still struggling with that one.
We all are.
Yes. Okay. So anyway, so here's a way of testing a query. So this is using a command line tool called curl. And so here I'm feeding it the URL. And so because I'm using the -v option, it tells me what it is it's doing under the hood. So first of all, it's trying the IPv6 address. And that doesn't work because my ISP won't let me do inbound IPv6. And I asked them about it. And they said, we'll do it when people ask us about it. And I said, okay, how many people have asked you about it? And they said, counting you? I said, yes, 1. So then it tries IPv4. And in this particular case, it worked. You can tell because it says connected. And so then it's doing a scheme called get. I'm sorry, a method called get, which is the default. And it's passing it the path, who am I? And it's telling the server to use protocol HTTP/1.1. Now, there are 5 versions of HTTP that are common use. There's 0.9, which is obsolete, 1.0, which is also obsolete, 1.1, which is in the process of becoming obsolete, HTTP 2, which is the new version that you should be using, and HTTP/3, which is on the horizon and it's coming. And so then the server would like to know what my host name is, and the reason why is because you can have multiple virtual servers on the same web server. So if I use jeffsilverman.ddns.net, that would go to a different virtual server than Jeff Silver M. So then, then it's telling the server what my user agent is, and that's the version of curl. And so if I wanted to be clever with my user agent, with my server, what I could do is I could, for example, detect if Google is using their spider and allow them in, but if somebody was not using the spider, I would keep them out. And that would be really wonderful because people would know what I've got, but they would have to go pay for it before they can actually get there. So if you want to know how to make money off the internet, that's how you do it. Of course, you have to have content that people want, which is another problem, but I will leave that to your creativity. And then this is a different query. In this case, this is IAM, which allows me to go change the name. And this example actually isn't quite right because I should be using put or post instead of get. But as it happens, it doesn't matter because my web server is looking at the path in order to figure out what it is it has to do. So there's more than one way to do this. And then everything else is the same. It's still trying to use IPv6 and failings, using IPv4 and succeeding. curl now is considered obsolete, and I didn't know that until I started researching for this presentation. One of the neat things about presentations, and I really encourage you to go do presentations, it's amazing how much you learn in the process of preparing for these things. I didn't know that I didn't know about HTTP. I did not know that I did not know about HTTPX until somebody asked me about it. So this is basically the same thing. I'm sending it a query. The path is IM, but now I'm using the -p switch and telling it that there's a variable called name, and this is the value that I want to put in it. HTTPX is written in Python, so this is a command line interface to a Python library. So if you want to create your own web diagnostic tools and you know how to program in Python, this is a way of doing it. So that was pretty cool. I wasted 2 days trying to figure out how this thing worked. So this is what happens when I change my name to Jean. Come on in. I won't bite you hard. So and one of the things that I find interesting about this particular example is you'll notice that first of all I've spelled Jean-Luc incorrectly, and second of all there's the %20, which I've spelled a whole bunch of things incorrectly. So the %20 is a encoding for a space, so that there are no spaces in the name. It's actually just a sequence of ASCII characters, and that makes it a lot simpler for the software at the server side. It doesn't have to go deal with white space. So then what it's telling in this case is that it will accept gzip encoding. So that's one way of doing text compression. And there's also deflate, which is another way of doing text compression. And it's telling the server that the user agent is Python HTTPX. So the server knows that this is someone using HTTPX. And if they are concerned about that sort of thing, they can take the appropriate action. So for example, if I was concerned about hackers, this is something that I might want to know. I'm not going to go into HTML forms too much because this is a class in browsers and not in HTML. If you're interested in forms, take a class in HTML. So I have a demo form, and it's on my web server. And let's see if I have a version locally, because I think I do. Okay. Now, you may have as much trouble reading this as I do. So this is an example of an HTML file that's got a form in it. So the form starts with this tag right here and goes down here. And then inside the form is a description of what the form actually is. So there's a comment. So here is a label for name. It has, here's a prompt for name, so it matches up with this label. Here is the input ID. Here's the variable name that's going to show up at the server. Here's another name for the same reason, because there are two different standards for what this attribute ought to be. And then the value is enter your name here, which will be some text that will show up in the text box. This required means that the browser will generate an error message if you haven't filled it in. You will not be able to autocomplete it because some browsers will autocomplete. This says don't do that. And then this says the type of field, which is a text box. Then down here is a description for a button. And the button is labeled submit, and its value is weird. Type is submit. So, and then the key is this here, the form action. So this says go to my website, port 8081, with the path I am. And it uses the method get. Now I could make this a lot more complicated if I wanted to, but this is complicated enough and I'm getting a headache anyway. So this is what I left it at. The button is clearly labeled submit, so you know what to go punch. And that tells the browser that the form is now complete, send it to the server. And again, if you want to go be a website designer, you'll need to know this, but there is so much more. And I'm already running out of time, but I really wanted to show you this so that you know what's going on under the hood as far as how the server and the browser interact with one another. And there's my mouse. Now, different browsers have got different levels of compliance, and the compliance level of browsers have gotten better over the years. It used to be that you would see sites that say this works well with this browser, or this site works with this browser, and sometimes I would come up with problems with people's servers with their HTML that they're sending out. And I would call them up and talk to them about it, and they say, what operating system are you using? And I would say, Linux, what's that? But anyway, so I tested all these, and I've got 7 minutes, so I think I'll skip it for now. But these are all websites that do various benchmarks, and let me take my heart into my hands, and let's do, this is Basemark. So just click on start, and so it's doing some of these compute tasks in either JavaScript or in Web ASM, and it's measuring how fast this thing goes. And I think just in the interest of saving time, I'm going to stop it prematurely and move on. You're welcome to go off. Obviously, I mean, they want this to do this. The HTML5 test did not work on this browsers. It went into a loop, and at one point I let it run for 2 hours, and it still didn't finish. So classic example of the Turing halting problem. So now this is the slide that I promised everybody I wasn't going to talk about. These are the protocols and the troubleshooting tools that you should use. And this is basically a quick synopsis of a class that I gave at Linux Fest last year about troubleshooting home local area networks. So this is using the OSI model, 7-layer model. If you want to use the TCP model, then all of these in green are the application layer. The transport and the internet are still separate layers, and then the link layer and the physical layer are combined. The colors mean that this layer down here is being handled at the interrupt level, because when a packet comes in, the device driver has no idea which process it's got to go to. So it's doing a system-wide interrupt response. Then it passes that on to the kernel, which figures out where it's got to go, and then it goes all up to through the libraries, and eventually gets to your application, which is what actually is doing all the work. Then here is a way of testing a site to see if its certificates are good. So this is using OpenSSL, which has been around for a long time. And there's only one man in the world who understands it, Eric Riscola. And if he dies, the world is in deep trouble. He wrote a really nice book on the subject, which is still good, even though it's been well over a decade since he wrote it. But anyway, so here I'm testing my own website, and what I want to do is I want to see if my certificates are still valid or not. And what I see is that my certificate is due to expire next week sometime. So I really need to go and renew it. And so that's on my list of things to do. Then I came across another tool called SSL Lies. And let's see, I think I can do that in the time I've got allowed it. So let's see, Python, whoops, come back here. Python 3 minus M SSLYZE Jeff Silver M dot edns dot net. Okay, and this is probably something that okay, now I want to slide this over there like that and push the button. Oh, that's because I'm using my test URL. There we go. Okay, so so this produced a great deal of information, as you can see. So it's looking for the certificates. It found one. It checked that the certificates were had proper footprints, so fingerprints, so that it knew that it hadn't been forged. This is the DNS name. These are all sorts of checks about the validity of the certificate and the chain of trust that goes back to a root. So it can actually trace it all the way back to the Internet Systems Research Group, and they've got a root called X1, which is very popular all over the planet. I'm not sure what the 2 SCTs warning is about. So Google recommends 3, but that's great because Google's got a multi-billion-dollar IT budget. So then these are all obsolete suites that should not be used, and the server rejected them, as well it should. And then here it connected up to tested 156 cipher suites, and it accepted these 27 that it shouldn't have. And so that's where it gets down here, and this is why it says that it failed, because it's got whoops, not quite there yet. This is why it failed. So Mozilla has a intermediate security configuration, and these are things that should be rejected that aren't. All right, so now I've got 1 minute before this session ends, and I have lost there it is. Okay, so I've got 1 minute left, and there's some more things that I'd love to talk about, but I don't really have time for it. So basically, oh, this is good enough. So these are some of the tools that I've talked about in this presentation, are some of the things that I've talked about in previous presentations that I've given, both at SeaGL and at Linux Fest and at Python meeting in Vancouver. But if anybody has any questions, now is really a good time to ask them. Does anybody have any questions? Anybody still awake? Oh, that's 2 people, 3 people. Great.
I thought this was going on for another 30 minutes. I think there's a break.
There is some sort of a break, yeah.
Yeah. Well, let's see. So this is, see, according to this, my notes, it's supposed to go to 15.
Oh, it was my mistake, sorry.
Okay. So according to my notes, I'm supposed to stop at 1600, which is in 9 minutes. And then there's going to be another presentation here called Opening Up the World of WebAssembly with Guile Hoot.
Which is 1640. So
1640. Oh, but there's going to be the Teagle.
Yeah.
That's the break.
Yeah.
Teagle. So we're all going to go downstairs and drink tea, except I don't like it, so I'm going to have hot chocolate. But anyway. Anyway, so anybody else have any questions? Great. So I want to thank you very much for attending. This is probably the last presentation I'm going to give because I'm retiring. So this has been kind of a, well, I'm getting kind of old and crotchety, you know how it is. Somebody asked me what the most significant event in my life has been as of late, and I said, oh, my Medicare card arrived. And the first thing it said is, you get a welcome to Medicare appointment. And I'm looking at it and I'm saying, Welcome to the Medicare, the spider said to the fly.
Alright.
Anyway, so yeah, I'm going to be around tutoring or something like that, and maybe I'll give another presentation. It depends on how hard people twist my arm. But anyway, yeah.
What would you be tutoring?
Python, Linux, local area networks, physics, mathematics, poetry.
All in the same session.
Amazing tech talk.
Like I said, some people are really good webmasters.
I didn't know that you could tutor like systems administration.
Well, someone's got to do it. Actually,
It's a lot of rolled up newspapers.
But yeah, there's a company called Code Cloud, and they have hired me to go develop a course in how Nginx works. And that's another example of when I started getting ready to teach something, there was a whole bunch of stuff I didn't know. So I was having a discussion with my son the other evening, and he's got a BS in CS, so he's more qualified to do this kind of stuff than I am. And he said, "Did you know about awesome Nginx?" I said, "No." So it's a Git repository. So I go there and take a look at it, and they've got on the order of 100 different projects that people have done to go extend and refine Nginx in all sorts of wonderful ways. And I had a meeting this morning with the guys, and I said, "There's a whole bunch of stuff that I didn't know, so I'd like to cancel the meeting and meet again the week after next, so I have a chance to go understand this stuff." And they said, "Oh, that's great, because we're not ready to meet with you either." Dodge that bullet.
What was the name of the place where you're developing courses for?
It's called Code Cloud. KODEKLOUD.com.
What'd you say?
Cloud with a K?
Cloud with a K, yeah. Really good computer science company, not so great spellers.
Is that Microsoft PowerShell? I
Jeff.
told Microsoft PowerShell.
Who said that?
I
Oh,
did.
yes. Thank you very much.
I invited you the first year, so I
don't recognize who you are.
Rob, but yeah, so I invited you to speak the first year, so.
My name's Rhea.
I'm just gonna make things more complicated.
For like a few years
Where you at,
ago.
John?
All we do is we
file that actually has a
live this here like this, and well, one thing we do is we come over here and we just press M. M mutes MPV.
Okay.
And then we juggle these, and this, ha, ha. Oh, okay, great. So this is picking me up here. I'm gonna go stand over here and talk. Does the microphone pick me up over here if I'm talking?
Yep.
I think it's that one built into the ceiling.
Okay. I see.
I wonder if there's anyone tuned into the stream right now listening to this. All right, how about way over here at the window? Does the microphone pick me up over here?
Yes.
Teacher, but why is the event special? All right.
Does this look like? Is this your back?
Yeah, I think so. I never see it anymore. I just have full screen window. So let me. Let's see. What have I got for displays? Yeah, I see the 2 displays. What I need is to get my browser window over key.
To be.
Oh, well. Glad to hear.
Oh,
Happy
yes.
to hear that.
That makes sense.
Yeah.
We're gonna tear it apart.
No, they just
Hardly, not sure we couldn't do it.
Yep.
That has
This project didn't really work out, so we're just gonna.
Geez, don't tell me that.
Okay, we're gonna do
So we gotta do the fix.
We're gonna do magic.
I am the
Okay,
guy
so
who read
unplug
those
this,
posts by
unplug that, unplug
C.
that.
Weber and
Yeah,
was
plug in the first
tried to do
USB,
the tried to go through the
then
whole thing.
the stream
Oh,
is
really?
on top.
Yeah.
Oh, good.
But
And
I'm
then
pretty weak. I
yeah,
got stopped though by the nightly build of the browser.
had it for a split second.
Well,
Oh, yeah, that
it's-
takes a while.
That is.
Okay,
I did
so-
build the whole thing though. I built the whole thing.
And start the recording.
Okay, so your talk start. You can run this.
Yep.
Thank you, Hansam.
don't know
It's
this
recording.
one.
It's streaming. That is the microphone in the ceiling, and it will pick you up wherever you're sitting.
Okay. Is there a camera, or is it just getting the screen?
No, it's just getting the screen. We
Okay.
thought we had cameras, but we don't have cameras. Thank you.
Alright, I'll start at 7:40 because I know there's more people that are going to attend.
Oh
this
yeah,
better than-
yeah. You're gonna get more people.
Okay. The one thing I'm unsure about is that when I put this in full screen. Oh, there we go. Okay.
Okay.
I full screened it first, and then it like popped up full screen on my display that I'm seeing here, and I'm like, no, that's not right.
Are you running Geeks?
I am.
All right, excellent.
I should have maybe like just like mirrored the displays, but we don't. We have 2 displays, and that's gonna be fine. But yeah, I know there's other people coming, so we're just gonna hang tight for a few. Even though I know about the room 2, 3 being switched, I still went to room 3.
Yeah.
Did this, and I was like, no, it said room 2, but then I translated in my head to
They're all
room
messed
3,
up.
but I'm actually here.
They need to put. I mean, it was so simple to just put an agenda for the day on the room.
The
Right,
agenda for the day
right outside on the window. Put
Yeah.
a piece of paper up there saying, "Here are the talks, the times, all day long in
I
this
think
room."
tomorrow the rooms
That
are
works.
different.
Yeah.
Yeah, the rooms are all different tomorrow, and there's more rooms. I think there's more
Oh, really?
talks
Okay.
tomorrow.
Oh,
in general.
yeah.
Yeah. There we go.
Yeah. Okay. Do you need anything from me, or do you have any questions?
I just want coffee. So I'm gonna be back maybe in.
I can grab you a coffee if you want. Sure.
I'm gonna set our when we actually start.
Like, that's what you want. Like, sure.
That's stuff
I'm gonna set this up just so we.
Just frame.
Yeah, that
I'll be back in like
Just so we're aware.
5-ish. I gotta check on the other room.
Not sure how they actually correspond to the slide, but yeah, just
Yeah, I just want to know if we got to be double step at any point. We'll go in just a few minutes. What do you think? You're going? All right. I think we're a minute early, but I think it says 4:39, so thanks everybody though. So hey everybody, welcome to our talk. This is opening up the world of WebAssembly with Kyle Hoot. I am David Thompson, and this.
And I'm Robin Templeton,
both-
and I'm the compiler engineer working on Hoot.
Yes, and I'm the core infrastructure architect working at Sprightly. We both work at Sprightly. Robin's completely dedicated to this Hoot project we're going to be talking about today. I am kind of a part-timer on that. I do several things. So we're going to be talking about WebAssembly today in some detail. But first, just to give a little overview of the organization we work for. Sprightly Institute is a 501c3 nonprofit research institution. We're trying to build essentially the next generation of decentralized and secure infrastructure for online network communities. And on to the next slide. So we're just about a little under 2 years old, and to do this research means we need to collaborate with all sorts of people. And this is just a short list of both funding sources, and institutions that we work with. So here we work with Agalia. There's someone by the name of Andy Wingo's the lead engineer on the Hoot project that we're going to talk about today. He's from Agalia. It's a software cooperative in Europe. And MetaMask has given us the grant money to work on this. But a little bit more about what we're working on with Sprightly and why we're doing this WebAssembly thing in the first place. We're working on a distributed transactional programming environment called Goblins. And we're trying to make secure distributed applications easy to write, and with a security model that you can understand. And our motto is, if you don't have it, you can't use it. And that's our motto around what we call object capability security. It's not the subject of this talk, but it is kind of the overarching mission of the technology we're working on. And it does interesting things. We build distributed applications, and we also have useful tools like tools to debug distributed applications. And for example, we can generate, this is a diagram, a time series diagram called a Lamport diagram, if you may know that particular term, of something of a asynchronous operation happening between three machines that our system can determine the causality of events in, and then present a printout. So these are just some examples of the bigger projects we're working on. We're also involved in standards. We're looking to not only build our own technology, but to develop standards that are interoperable with all sorts of other systems, written in other programming languages for other operating systems, etc. We're working on something called the Object Capability Network, which this is a neat diagram that we made, but don't worry about it. It's just a neat animation. But it's the important thing is this is about developing a new networking protocol for distributed secure applications that is usable across languages, across systems. And this is a cross-functional effort and a cross-organization effort, and we're in the pre-standardization phase right now. And we'll be looking to develop this further. But again, this is a little context of what we're doing. So we're trying to build secure distributed applications. And we want, ultimately, not this to just be a research project. We generate papers and things like that, but we also want to put something in the hands of users that they can use, and we can demonstrate the ideas that we have and the research that we're doing. And this is where we come to this talk. Everyone has a web browser. That's where the users are, and that's where we like to meet them. However, we made a deliberate choice to use what you could say is a somewhat obscure programming language called Scheme, and a particular implementation of that language called GNU+. We didn't choose JavaScript, but we want to be in the web. What are we going to do? And of course, in the title, we're going to use WebAssembly to do that. We are going to compile Scheme to WebAssembly. And we're not alone in wanting to do this. There's lots of people out there that have their own languages and tool chains that they'd like to use and to deliver to the web. And so this talk is going to be a little bit bigger than just Goblins and just like what we're doing at Sprightly. This is going to be about everyone else. They also need WebAssembly. And Robin, I'll tell you straight up that I forgot to start the stopwatch, so don't even worry about that.
No worries.
And this is where I hand it over to Robin to give a little background on WebAssembly before we get into details.
All right, so WebAssembly is an open standard from the W3C. It's been in browsers since about 2017. and we'll give a little bit of context on why WebAssembly is interesting and important. So for one, it provides an alternative to JavaScript for programs running in web browsers. It's a lot simpler as a compiler target for non-JavaScript languages, not just low-level languages, but also higher-level languages that don't match JavaScript semantics in various ways. It also has a capability-based security model, not unlike the one we're implementing in Goblin, so that's very interesting to us. It's been Mozilla is using that in Firefox for hardening some of the C libraries they use, for instance. Production runtimes for it are quite fast, usually within about 10% or so of the speed of native code running in a web browser. And there are also various non-browser applications, which we won't be talking about much today, but there are a lot of sort of competing on the edge sort of projects and non-browser runtimes that are using WebAssembly. Okay, yeah, sorry. Let's do your job.
All right, so I want to talk again. Just a quick thing, a little bit of history if you're not familiar with where JavaScript came from, and this will be relevant to us. So it's the year 1995. Netscape wants to add a scripting language to Netscape Navigator. I can see people nodding. Some people already know this story. I imagine some don't. Netscape hires Brendan Eich with the promise of Scheme in the browser. That's a direct quote from something he wrote on his blog. I think I read this from a blog post around 2008. Thank you, archive.org. However, Netscape also contracted with Sun Microsystems, the original developers of Java, to add Java to Netscape Navigator. And an internal debate ensues. Oh, hi. Sorry, someone I've only ever talked to on the Fediverse is here. Welcome.
Well, I came just for that reason. By the way, sorry.
So Netscape starts debating, we're making the scripting language, we're adding Java, why two languages? And after all this debate, management says to Brendan Eich, okay, the scripting language you make, it's got to look like Java. So Scheme in the browser, that goes out the window. And what we end up getting is, JavaScript used to be called Mocha, finally lands on JavaScript. It incorporates elements of Java, elements of Self. If you ever wondered why JavaScript's object-oriented programming is a little weird, it comes from a language called Self, and has some of the features of Scheme, such as first-class functions. Some of the best parts of JavaScript are the ideas come from Scheme. And so basically, spoiler alert, I'm going to get to is here in 2023, what do we got? We're going to have Scheme in the browser like was originally intended. But now a little bit more history, get a little more recent. I'm going to hand it to Robin to explain this one.
Yes, so in 2013, Mozilla developed asm.js. So this was, of course, after JavaScript was the universal and only choice for running programs in web browsers. And there were various techniques for compiling other languages to JavaScript, usually not particularly efficient. And asm.js is a strict JavaScript subset that gives you just some techniques for compiling lower-level performance-oriented programs for web browsers in JavaScript. So you only have a few data types to work with in asm.js compatible programs like floating point numbers, integers, loops, function calls, etc. No higher-level constructs or object-oriented programming. But it is a JavaScript subset. So it did run in other web browsers, but Firefox had the performance advantages of being able to recognize the subset, and so it ran much closer to native speed in Firefox, and that forced other browsers to also implement it. And it was a pretty clever hack, but it has various disadvantages. One of them being that you have to, parse JavaScript, and it's a very verbose. It's very verbose written out because of various type coercions and things you need to write in, and so something better was required, and that leads us to WebAssembly. Let me make sure I'm not
Yeah, there we go.
Yes, sorry. So WebAssembly 1.0 was pretty similar to Asm.js as a target for compiling low-level languages to run the web browser. So you essentially had a few numeric types and flat memory model. So you could feasibly compile, say, a C program, like an interpreter for a high-level language, to run in WebAssembly. One of the problems is that it has no garbage collection. And that, of course, introduces problems when interacting with the browser APIs because the two garbage collection systems aren't aware of each other, and so you can get cycles between JavaScript and the programming language you're implementing and things like that. And also, it's just a bit silly to have a very high-performance native JavaScript garbage collector and not use it for the other language that you're running in the browser. And WASM 2.0, which is being developed, is WASM for the rest of us, as we like to call it. So it introduces a garbage collection integration with the browser, as well as higher level data types. So basically structures of typed fields, arrays, and 31-bit integer values, which get used for various immediates like true and false constants or small integer values in dynamically typed languages. And most importantly, that by using those data types, which are higher level than just manipulating a large byte array of memory as you would do in WebAssembly 1.0, that gets us integration with the host garbage collector. And so we'll take a closer look at how we're using WASM at Sprightly to bring Guile to the web. So how many people here have heard of Guile before? Okay.
More than I would have
no.
expected, honestly.
Yes,
Yeah.
Our guess was lower, but Guile is GNU's main scheme implementation. It's very flexible. It supports R5RS, which is sort of still a common denominator of scheme standard versions, as well as a good number of libraries and extensions. It has a good C runtime with a bytecode compiler and a native JIT compiler. And we're not going to get into this, but it can also supports non-scheme languages using its compiler system, including, for example, Emacs Lisp and a subset of JavaScript instantly. And I think there are projects to work on, for example, Python and Lua, but Scheme is the main target. And as a GNU project, it has been used mostly in Unix-like environments until now with Guile Hoot. And so we did face some implementation decisions when we were starting out the project because WASM GC was still experimental and non-standardized. So option one would be just to compile the Guile virtual machine via mscripten or something. Take the C source code, produce something that can run in a browser, and that would have been very quick to do. But there would have been performance trade-offs, but more importantly, there would have been poor integration with JavaScript, which is very important to us when we want access to all the native browser APIs and the document object model and so on for our actual programs. And so option two was to use the experimental garbage collection extensions for WebAssembly. And that was a bit of a risk at the time, as again, they were experimental and changing quite a bit. But it means that we get better integration with the WebAssembly runtime. The WebAssembly output is a better match for the scheme programs that we're actually compiling in terms of how it represents scheme objects and control flow and so on. And we also get good integration with the JavaScript APIs that we want access to. And so we went with option two.
So Introducing
Guile
Hoots. So we just released 0.1 in the middle of October, and we expect 0.2 to follow not long after. But to recap, it's a Scheme to WASM compiler project, primarily. It also, interestingly, includes a full WebAssembly toolchain, which we'll talk a little bit more about later. And just to, again, to reemphasize, this is not a C runtime compiled via Emscripten, which is kind of the norm right now in the WebAssembly space. This is a new implementation of the language, specifically Guile Scheme for WebAssembly. And our lead engineer, Andy Wingo, has described this in other talks as bringing your whole self, bringing the language in true to form to the web and making very few compromises compared to compiling to JavaScript or compiling to WASM 1.0. So we got 3 goals. Primarily, as we said before, we want to run Goblin's applications in the web browser and get them to everybody. But there's some secondary goals. We want to advocate for all dynamic languages in the WASM ecosystem. Again, WASM 1.0 was very good for the Cs and the Rusts of the world, but it was very bad for any higher level dynamic language that might replace JavaScript for what JavaScript does. We're making our own decisions to use Scheme for better or for worse. We love it, but really, like, being present in this space means we're pushing forward the technologies for any dynamic language to be here in the browser running on WASM GC. So Ruby, Python, other browsers or other languages. And third, as we got into this project, we realized what we really needed for ourselves was an alternative toolchain. The tools that are used right now in Emscripten, binary N, and stuff, as we got more into the project, there were things that they didn't support that we needed out of them because we're working with like experimental proposals that hadn't been fully accepted into WASM core, et cetera, et cetera. So we had this mismatch between what we wanted to go and what the tools would allow us to do. And so what we ended up doing was rolling our own toolchain. And we think it's a very useful toolchain and that other projects might be able to leverage it too. So I'm going to get into like a quick example of some Scheme code. If you don't like parentheses or know what Scheme is, don't worry about it. This is an update loop. It's a stateful imperative nested loop for updating a 2-dimensional grid for a particular cellular automaton. It's not the game of life, it's something else. But anyway, here's some Scheme code. Can we run it in the browser? Of course, I wouldn't be standing up here if the answer was no. So go ahead.
This presentation is running in a web browser, just to clarify.
Yes. So, and I don't know how far I can get into this here because it's on here, but this is, and I don't think I'm going to do a very good demo, but like watch because of this. But this is WireWorld, and it's a circuit simulator. And what I'm going to do, very poorly because I'm on this other screen, I can't. Don't worry. This is like, I knew this was going to like not work very well. Anyway, I got to erase this. I just want to show you that it works. I'm going to put an electron here just to show you that it animates. I'm going to press the space bar. And so what we have here is, I won't show you anything more advanced, but anyway, that obviously wasn't a pre-recorded GIF because it would have looked a lot better than that. But this is a circuit simulation. You draw copper, you put electrons on there, and with this very simple rules, you can actually simulate logic gates and things like that. If you're interested in like cellular automatons, you can go like wild with this thing. But in any case,
Turing complete.
yeah, this was our first attempt to bring a small program into the web that was described with Scheme. So we want to go a lot further than this, of course. But hey, there it is. That is Scheme code compiled to WebAssembly driving an HTML5 canvas. All right, so it's not just us that are building things with this. Since we released 0.1. Other people have been jumping on board. Does anyone here know the System Crafters YouTube channel for like a lot of geeks and Emacs stuff? Yeah, okay, good number of people. David Wilson, who goes by an alternative name Flux Harmonic when he does game development, recently participated in the Lisp Game Jam on itch.io, and in a week he made this like cyberpunk version of Solitaire, and this is using 0.1. This is using the version that we have released, like the publicly available thing. It's all publicly available, but officially released as like a stamp of approval, this version. So people are already building stuff with this and having a pretty good time. He streamed this whole thing, building it, I think like 6 streams over the week, and it was pretty great to watch. So we were also on the System Crafters live stream to talk about Hoot a while ago, and this is the title card for it, The Future of Scheme Hacking. Isn't that great? So what's the status of Hoot right now? Okay. We have most of a small scheme standard, what's called the R7RS small standard. It's quite minimal. It made it very good, like MVP. We have nearly all of that there, almost complete. We have some Guile-specific features, most notably something called delimited continuations, which I see some schemers in the room like kind of nodding along. But for those that don't know, it's a way to implement lightweight concurrency, like green threads, if that's a term, or like Go routine kind of things inside of Scheme. So some people say that like WebAssembly can't really do continuations or anything right now. It's not ideal, but they can be done, and we do them and we use them. And it also comes with a JavaScript interop library. So it's for inspecting scheme values from JavaScript, and because ultimately a WebAssembly module in the browser has to be instantiated by a little bit of JavaScript glue code. So we needed a JavaScript library. It's very small. So I'm going to hand it over to Robin here to talk about how Hoot compiles Scheme.
And so with Hoot, this is not quite a traditional self-hosted bootstrapping Lisp environment. We're using a Guile's compiler toolchain to do this. And so we're taking a Scheme, and Guile has, we won't go into too many details, but it has a compiler tower that can support, again, languages other than Scheme, but we're targeting Scheme for now. And it goes through a few different stages of intermediate representations, ultimately resulting in something called continuation passing style, which has similarities to traditional static single assignment style used in a lot of like imperative language compilers, so we can leverage a lot of the optimizations and theory that go into that work. And for Hoot, we stop at the CPS, or normally we would compile it into Guile's high-level bytecode that gets interpreted by a C program. But for Hoot, we, instead of generating Guile's bytecode, we compile it directly to WASM. And that only required tiny changes in the CPS stage of the compiler, the lower levels, as well as a Hoot, or a WebAssembly toolchain.
Yeah, so we replaced the last step and got to reuse everything else.
Yes, and so that gets us all of the optimizations and so on that have been going into Guile for the last 30 years. So we need some features from WebAssembly. We need garbage collection, again, for the higher level type system, as well as integration with JavaScript garbage collection so that we can use browser APIs for things. We need tail calls for efficient recursion. So tail calls allow recursive function calls to be as efficient as iterating loops. And we also need strings. That's a bit complicated, but this is an example of future work on WebAssembly. There's an extension that we support in our toolchain called StringRef that was proposed and is being championed by Andy Wingo. And it's a bit up in the air as to what browsers will ultimately support, but we'll get back to that. And so Chrome 1.19 was just released and supports everything we need for Hoot. This is running in Chrome nightly, and Firefox 121 will also support this fully. So that's coming out in a few weeks. So we're expecting this to be running in all major browsers by early 2024.
Just a quick thing. Firefox 120 is coming out in a few weeks. That'll have GC support. Tail calls got bumped recently, so Firefox 121, end of December, will have everything that Hoot needs.
Right.
And that'll be at least 2 out of the 3 major browsers. Safari is a little behind. Sorry. Go ahead. All right. This is where I take over. Yes, of course.
Yes,
so
over to Dave for our WASM tool.
So Hoot's not just a compiler for Scheme. As I said, it's also a toolchain. And it's actually a library of WASM tools. So this toolchain is self-contained. It requires nothing other than Guile to use. No other tools. If you have Guile, you have the Hoot source, you're good. It's nice and contained in that way. Not a lot of dependencies. And so it allows you to write, compile, and notably execute WebAssembly all in one place. And so again, this is an alternative to the mscripton, binary, and Wabbit tools that are most often used right now, and I suspect will continue to be most often used. But so this tool chain is primarily available as a set of scheme modules, and what this means is it's a library. You have programmatic access to all of this stuff. So a lot of the mainstream tools, I mean, there are things that you integrate via command line scripts and things like that into build systems. We have that too. Guile has a tool called Guild, which is traditionally the thing you extend with additional command line tools to access the compiler. So we've extended Guild, and via that you can hook into build systems just like you would with any other tool. But it's really that library that's the key selling point. I don't know of any other tool chain with such granular access to the inner workings of the tool chain via libraries like this. So this tool chain contains a WAT parser, which is a funny way of saying WebAssembly text. That is kind of the human readable form of WASM. If you want to get that low level and hand write WASM, that's what you use. When you're implementing a compiler, you end up having to write some of that. Has a binary assembler, binary disassembler, has a linker, which allows us to take a WebAssembly module and add in like a standard library. We have a standard library of WebAssembly code that needs to get linked in to whatever user code we compile to produce a working module for Scheme. We also have something to take a binary and give you a printout of everything that's in there, the functions, the type signatures, all those things. And we also have a WebAssembly interpreter. So this is an interpreter for development purposes. So it's not fast. It's on a production WebAssembly runtime, but it supports everything that Hoot needs, and it allows for a tight feedback loop while you're developing. It allows you to not only compile the code, but also to test it all in the same environment and get quick feedback like that. You don't need to jump into the web browser or into another WASM runtime. So to talk a little bit more about that development environment, as I said, it's a built-in interpreter. It validates the code, validates the WebAssembly binaries, which means it checks for type safety before it executes. And you don't have to leave Guile to do this. There's a small set of debugging tools that allow you to inspect the WebAssembly stack, the function locals, and other things. So if you really want to get in the nitty-gritty of what's happening in your WebAssembly program, like step by step, you can do so. You can get as verbose as you want with these things. And then when it comes to testing Hoot compiling Scheme to WebAssembly, we have Scheme in Scheme reflection library. And it's getting recursive here, right? You're in Scheme, and you compile the Scheme to WebAssembly, but then you run the WebAssembly and you get Scheme objects. And well, you can look at all this stuff and inspect the values and work with them there. Yeah, sorry. So here's a quick code example. This is the Guile REPL. This is just like an excerpt from the Guile REPL. We import some modules. We use those libraries I was talking to you about to compile some WebAssembly text, the thing that starts with that single quote module, to implement a little math function. This takes a 64-bit float and computes a modulo of that between two values, dividend and divisor, and exports it via the name fmod. On the second to last line, we validate the binary that we get through that process. We instantiate it in the interpreter. And then in the final line, we pull out the exported function, which we can then call as any normal Scheme procedure and pass it the arguments, 4.3 and 2. And we expect that the modulo of that to be somewhere around 0.3. And that's what we get. So 0.29999, whatever, floating points, not exact. But so there's an example, just self-contained. We didn't have to go to V8 or anything like that to test our WebAssembly, which I think is pretty darn neat.
It's fantastic for interactive development.
Yeah, so you can kind of iterate this way on your stuff. If it didn't work, try it, modify it, try it again. You have a very quick feedback loop. And then taking it one step up further, we want to compile Scheme using Hoot to WebAssembly and then run it. What we do is we have a nice handy binary for reflection called reflect.wasm. We load that up. We define a procedure here called Hoot square, which is compiling that lambda that we see there. That's an anonymous function. It takes a value x and multiplies x by itself, so that's squaring a number. And then if we just type in Hoot square at the REPL, we see its printed representation. We see it's a Hoot value representing a procedure. And then we invoke that procedure with the value 4. and 4 squared is 16, and that's what we get. So we not only can test the low-level WebAssembly, we can actually test Scheme, compile to Scheme within Scheme. So kind of wild, but it's pretty fun. Okay, so that was kind of the most technical part of the talk. We're going to kind of go back up and start talking about some takeaways about where we're going, not only with Hoot, but the rest of the WASM ecosystem here.
Yes.
I'm going to hand it to Robin.
So for the future of Hoot, we are still working on a complete implementation of R7RS. We're targeting that just because it's a pretty minimal and modern specification. We also want more features for Guile compatibility, since Goblins is targeting Guile and uses Guile extensions and features, some of which we have already. We're actively working on a better foreign function interface to JavaScript to conveniently access browser interfaces. We also will be supporting the module systems for both R7RS and Guile. We'll be implementing the Fibers concurrency system, which is a prerequisite for running Goblins.
Then we'll get Goblins.
Yes, and then we will have Goblins running in a web browser. So the future of WASM also will have some impact on this. We've already influenced the development of WASM since we've been experimenting with the garbage collection proposal since before it was standardized.
You don't have to be Google to participate in the space.
No, it is a W3C organization, so the community group is very accessible and has various subgroups for topics like garbage collection and things of interest to different language designers. So we would like to get more developers of dynamically typed programming language involved, and we've changed things in the standard, and so can you.
And I realized that we have actually skipped over some interesting slides.
Oh, we have, yes.
Yeah. So so that's kind of the meta of the WebAssembly world, and it's not too bad of a transition actually to talk about some reflections now that we've been doing this for like over 6 months. Like, what are the good things about WebAssembly right now, and what are the bad things for dynamic languages? Robin, I know you were going to do this originally. You want to take it from here?
Sure. So WebAssembly text is S-expression based, so we can write it in Scheme syntax, which is really nice. It's easy to generate and manipulate in Scheme because we can just write as a data structure directly. We have tail calls. Have we mentioned that before? That's very convenient for a Scheme implementation to not have to have a workaround for that. And the type system is a pretty good match for what Guile does internally in its native virtual machine. So that has worked out pretty well for us. And in the other direction, besides using Scheme to manipulate WebAssembly, we also have been embedding WebAssembly into Scheme for use in the standard library. So it's about 10,000 lines of code split between WebAssembly and Scheme right now. So for a lot of the integration, we use inline WASM. This is which allows us to call an anonymous WebAssembly function conceptually from Scheme. And this is just a predicate to see if X is an input-output port. And you can see the WebAssembly syntax there with a function taking one parameter, which is a Scheme object, returning a Scheme object as a result. And it just does a simple test to see if the structure is in fact a port structure, and then returns the immediates that happen to represent true or false, depending on the result. So that's been very convenient for writing the standard library and integrating it with the WebAssembly bits. And there are also some difficulties. We mentioned strings earlier. StringRef is not in production hosts, so it's not in web browsers yet. There is a competing proposal, but we've been able to work around that by supporting the StringRef instructions in our toolchain and compiling that to something which actually works in web browsers but is a bit less efficient. Similarly, there's not support for delimited continuations or any continuations in WebAssembly yet. So we have a compilation technique that introduces some overhead into the compiled program. But there are proposals being developed that will add delimited continuations directly to WebAssembly, which we are hopeful that they'll be successful. And then also WebAssembly has limited constant expression types, and that introduces some overhead during program initialization. So nothing too bad, really. All things that can be fixed with future WebAssembly extensions. Yes, this goes into a bit more detail on string graph, which Andy Wingo is championing. And it's a pretty efficient proposal that should work efficiently in both web browsers and non-browser WebAssembly runtimes. And we're hopeful that it will be adopted because it will allow for calling browser APIs like the document object model interface without copying string data between Scheme and JavaScript. So that's obviously pretty important for efficient interoperability.
I think so. Now done that. So we'll jump back to where we were. So yes, the future of WASM. And yeah, so we're gonna conclude, and then we have a little post-credit scene with some teasers for the next release.
Yes, so move over JavaScript. Scheme is now another first-class language in the browser. We want WASM to have space for all languages of various paradigms, various levels of abstraction, and Hoot is for Scheme, but not necessarily just for Scheme. Other languages might find our toolchain and interactive development tools useful. And I will turn over to Dave to show off a few demos running in a web browser.
Yeah, so for our first demo here, this is a teaser because it's not out. The features that are used here are not out yet. Who here has any familiarity with the textbook structure and interpretation of computer programs? Got a few, actually a surprising number of people. Awesome. Yeah, so in that book, you build a meta-circular evaluator. It's a scheme interpreter implemented in Scheme. It implements a subset of Scheme in Scheme. So with WASM introduced, now things get a little funny here. This is a simple Scheme interpreter written in Scheme, compiled to WebAssembly, and then running in the web browser to interpret Scheme code. The UI rendering here, this is very simple. But it's also written in Scheme, and it uses a foreign function interface to make DOM API calls to generate all the the interactable elements on the page. So this is almost entirely a Scheme program with a small amount of JavaScript glue code to just provide the capabilities to the WebAssembly module to do all of this. So, we have numbers, we have strings, we can do lists, we can add numbers. Isn't it amazing, right? Like, what else do you need? We can make a function. This is using the squaring a number example again. Look at this. We have that. I don't know why that tooltip is like not going away. I don't understand that. But in any case, we can square the number 4. Wow, isn't that great? So it's not a GIF. This is a live demo. It's a long way from having the whole compiler hosted in the browser, but it's a step along that way. Okay, we're starting to be able to interact with actual Scheme expressions at runtime. So this is a step along the path towards having a fully interactive Scheme environment in the web browser. So that's step 1. And if I click out of here, so that's cool, very programmery. How about just like, I'm gonna quickly switch to a different tab. I made a game. And Christine Lemmer-Weber, the CTO of the Sprightly Institute, did the art very generously for me. So here we go. I'm going to click. All right, and I'm gonna mute this music for now. But this is a space shooter video game that was made last week, and this is written in Scheme and uses the foreign function interface to drive an HTML5 canvas. And you see it's running at a pretty decent clip. It's not noticeably lagging or anything like that. It's not particularly optimized, and it's just using HTML5 canvas, not using WebGL or WebGPU, anything fancy like that. But yeah, so we have this. So these are the kinds of things that you can do. This is taking advantage of delimited continuations, by the way. All the entities in the game world are scripted with this to do coroutines. So that's all happening here. It's pretty neat. So we're already able to do some pretty impressive stuff, even in its rather, this is kind of an alpha state of the project. To conclude, we are a research institution. Like, we want to work with you in this room, people on the stream, anyone hearing this. Either, we've always accepted donations, but more so like, try this if you're interested in. File bug reports, make something. We want to hear about it. Do you work for an organization that has similar goals? Talk to us. Let's have a chat. Can we benefit each other somehow? We're always looking for sources of funding for our projects. Could you fund us? Let us know. Please, like we want to work with people. We're a nonprofit. We're doing this for the public good, for network community. For networked communities ultimately, and this is a community thing. Well, I guess if there's any time left, I don't really know. We can do questions, but I just want to point out there's the homepage for Hoot there. That QR code gets you to the Sprightly Institute homepage. We have a community forum, like a discourse forum. You can use the code OCAPN2023 to join it. And we're also on IRC, on #Sprightly, on the Libera chat network if you're into IRC. So there's many ways you can talk to us. File bugs on GitLab or something, But yeah, if you're into this, come talk to us here, online, anywhere. Thank you for your time. You're in charge of the room. Do we have the time for questions?
Yes, we have time for some questions. Not too much time, but yeah.
Okay.
Just so the REPL that you've got running there is very nice.
Thank you.
Is it possible, or would it make sense to someday have a REPL that could run standalone, like in a CLI?
Oh, interesting. So you're talking about this running in WebAssembly, but in your command line?
Yeah, I mean, would it be an advantage over just like running a Guile, REPL?
I don't. Native.
Or is it even possible?
Well, I think it would be possible to do. Yeah, and I think what you're talking about would be more like, well, I think it would be useful if you were running in an environment that only allowed you to run WebAssembly, like an environment with strong sandboxing and security constraints. Then you couldn't run just a standard Linux executable if it only supported WebAssembly. Then I think it would be good. Otherwise, if you're just running on your own computer, I would say just run the regular Guile REPL. But yeah, there could be a use case for that.
I just meant
it's an interesting idea.
Feedback and having access to the ability
And
to command line.
I should repeat for the stream and anyone listening, the question was, would it be useful to have a Guile command line REPL like compiled to WebAssembly for this? And that was my answer. Yeah.
Thanks.
I should be better about repeating. Over there. Hi.
So a sticking point with other languages with WASM is that they don't have any debug info format that's standardized yet. But you mentioned you had a whole debugger.
So that was earlier in the talk, but I was trying to. We have a debugger for like our platform that we're building. WebAssembly debugging. You're very right. Oh, and to repeat the question was about debugging capabilities in WebAssembly. Yeah. They're not great yet, and they're still not. We don't have a magic solution to that. We are talking with some of the people in WebAssembly land about getting the information we need to say. In Hoot we don't want to. If something if the program crashes, we do not want to show you a WebAssembly runtime error. We want to show you a scheme stack trace, and we're trying to work towards that point to getting that. So if you're used to writing scheme programs, like if you're used to the Guile environment, which you presumably are, if you're involved in this on native or on WebAssembly, we want a very similar stack trace experience in tools like that. That's a work in progress, and that's going to require some WebAssembly facilities. Yes. And you're right, there's no standardized debug info. You can put certain things in there, like there's some support for the dwarf format, but it's not like that format was made for ELF executables. It's not a perfect match for WebAssembly. I don't know a whole lot about it myself, but debugging, pretty much everybody that's works in the WebAssembly space right now has complaints about debugging. So hopefully that's going to get fixed, but it's a bigger, WASM-wide effort.
We do have some debugging tools, like being able to take a backtrace from a browser, but yes, it's not something that's easily accessible from, say, the browser console so far.
I guess maybe what you were really asking earlier, and maybe I misunderstood you, was that, yeah, we do have some tools. So when you're interpreting WASM in our environment, in there, you have more insight than you would have in a production runtime. Yeah, because what we do is like it's an interpreter, so it's really slow, but we have the maximum amount of context that we can show you because of that. So it's just it's stepping through, and we can, if you want, you can be like really verbose. You can print every single instruction. What's the stack look like at that point? What do the functions locals look like? All that stuff. So they're kind of primitive, but they're there, and even primitive tools are better than what you get in what Google and Mozilla have made. Oh, hi. I'm sorry, Rob. I couldn't see.
It's okay.
Hi.
You talked a little bit about the sort of primary reason for motivating this work is that you want to be able to run goblins. But I don't know what goblins are because I came to learn.
Oh,
So
yes.
I don't know if I just came late and I missed
We
it.
did cover it, but no worries. We'll do the if we have a minute, really quick. So Goblins is a distributed transactional programming environment. It's a way of building distributed applications that are secure by default. That's the aim here. It uses something called object capability security. Don't worry if that term doesn't mean anything to you. It's a area of security research that actually WebAssembly takes inspiration from as well. So we're trying to build the infrastructure for network communities where you can have like intentional and consensual interactions with people online, and you own your security. That's the vision.
Great.
For Goblins.
Thank you.
So,
It's
yeah.
not a little gremlin. And then
Yeah.
you mentioned fabric or fiber or something.
Fibers,
like that.
yes.
Fibers are a concurrency system in Gauss scheme, which are a prerequisite for using the Goblins library. So we'll be working on support in WebAssembly for the Fibers concurrency.
So
Yeah.
that was the green threads thing or
Yep.
different? Okay.
Yep. So if you're used to anything like fibers, green threads, Go routines, these are more or less terms for the same thing. Yeah. The communicating sequential processes. Another. Yeah.
I think it's time to
I think
wrap.
it's time. Okay. Thank you. Thank you so much. Thanks for coming, everybody.